waiting for your third speaker. Yeah. Who's author to that? He's loaded. Oh, he's not in the business.
Okay, I'll be the person to start this.
You have to start from the stage, by the way. So give me your mic and walk. You need to welcome people.
Yeah, like now.
Morning, everyone. Welcome to day 3. I know everyone is bushy-tailed, bright-eyed, twinkly eyes, because I know you were all in bed by 8 o'clock last night, as was I. Let's have a good day. Everyone pay attention. No sleeping. It's going to be a good one. We've got some really cool talks lined up. And without further ado, let's get Kevin Gaston on stage for talking about personalized ecology.
Good morning, everybody. Thank you very much for the invitation to be here. It's great to be back in South Africa after what's actually been quite a delay, and great to see a bit more of your fantastic country. At the age of 24, I sat in this guy's office and struck a deal. For those of you who don't know him, this is E.O. Wilson. His office was in Harvard. And you could argue he was one of the big biology thinkers of his generation. He was a multiple Pulitzer Prize winner and a global expert on ants. I was a poor research fellow, and I was desperately after a free copy of the first book on biodiversity, which he'd just edited. Sat in his office, and he very generously reached under his desk to a box and pulled out a copy of this book. He signed it, and he leant across the desk to give it to me. And then he held on to it for that beat longer than you were expecting. And he said, "I'm going to give this to you on one condition, that you spread the news of the importance of biodiversity." So here I am, 35 years later, still talking about biodiversity. I'm wondering whether that's actually the most expensive book I own. I want to talk to you today about there's a clock ticking here which says I've only got 12 minutes left. I think I should have nearly 30 minutes. I want to talk to you today about personalized ecology. This is something you all have. You all have a set of direct interactions with nature, direct sensory interactions. And what I'd like to do in the next 25 minutes or so is unpack what that is, why it might be important, but also, whilst I'm doing this, to ask you to reflect upon your own set of direct interactions with nature. Maybe what they've been like on the way here this morning, what they're like on a normal day, what they're like at a weekend. What's an exceptional set of direct nature interactions for you? And here we're talking about the direct interactions, not all the other implications of nature. And those can take very many different forms. After Winnie's talk yesterday, I was reflecting on the fact that actually there's not a very Africanized image here, and maybe I need to be better about that in future. We can think about broad typologies of your personalized ecology. So what senses are you using? We focus a lot on visual interactions with nature, but there are also, of course, auditory ones. There are senses of smell, there are senses of taste. Predominantly, I guess, we're talking about visual and auditory ones. They vary in their immediacy. How close to, how immersed in nature are you? How important are those less immediate interactions for you, looking out of the office window and seeing a green scene? Some of those interactions you'll be very conscious of. Very many of them you won't. We only have a limited cognitive capacity at any one time, and clearly we filter out a lot of nature interactions much of the time. Some of your nature interactions will be very intentional. You'll purposefully go out to see nature or to have nature experiences. Many of them will be unintentional. They're consequences, passing consequences of everyday life. In that sense, many of them might actually be quite banal, and many of them are not exceptional. Many of them are also mediated. It's different levels of the extent to which we attract wildlife to ourselves. In Europe, many people feed birds in their garden, for example, bringing those nature interactions closer. Many of them are unmediated, except you could probably argue that on much of the earth now, almost all human-nature interactions are mediated in some sense by human influences. And then those nature interactions can have a whole variety of outcomes, both for nature and for people. They can be positive and they can be negative. I'm going to talk a lot about the positive ones, but actually we need to recognize that on both sides of that equation, there are lots of negative ones. Personalized ecology turns out to be an interesting conceptual that links lots of different ideas together. We can think about the causes of your personalized ecology. Think about how they shape the structure of those nature interactions. We can think about the consequences of that, and I will argue some of those are really profound. And then we can think about some feedback loops in there. And that's really the structure of this talk. Just to reiterate, the focus here is on your direct interactions. I fully accept that ecosystem services and the whole field of human-nature interactions more generally includes a whole other array of interactions. The fact that maybe some of the breakfast you ate this morning required pollinators in some other part of Africa, and you could argue that's a human-nature interaction, but here we're just focusing on those more direct ones. Each of the numbers on this plot on the left-hand side here is a different theory, a different concept across multiple fields, which sit within this realm of personalized ecology, and I've just given you a few examples here of lots and lots of things that you suddenly find are connected through this concept. Although curiously, it's been something of a bit of a gap in understanding. You could almost argue that we understand about the interactions that other species have with the wider set of interactions of yet other species better than we do about people. We really haven't. I think what's happened is that humans are something we don't study in ecology, almost by definition, other than as a pressure or as a set of benefits. We don't really study humans as such. And human ecology as a field has really been mostly concerned with political and social issues rather than actually what an ecologist would recognize as the ecology. So partly what we're doing here is actually studying people to some extent in ways that we would use to study other organisms in ecology. You end up crossing here multiple disciplines. Once you start thinking about your direct nature interactions, you encounter ideas that touch conservation science, ecology, evolution, education, medicine, immunology, leisure, and so on and so forth. Much of science, certainly in Europe and North America, interdisciplinarity is a lot of focus. This is a really interdisciplinary topic area. And as I say, amongst the consequences are really quite significant ones for the future of biodiversity and arguably people. I call these a personalized ecology because they are very individual. In fact, they're unique. Each of you will have a unique. Two of you could go and stand outside now, and you would have a different set of interactions with the nature around you. They're both personal and personalized because they're personal because they're unique to us. They're personalized because we also shape them by the decisions that we make almost on a day-to-day basis. Do I go left? Do I go right here? Or change my personalized ecology, where I go on holiday, the route I take to work. Odd to conceive that essentially everyone on the planet has a personalized ecology, maybe a richer or a poorer one, but it's unique to every single one of those individuals. You could argue that it's a sort of biodiversity fingerprint, if you like. We've just done a big study surveying people across the planet in 23 different countries, asking some very simple questions about their nature experiences and their nature interactions. Say, personalized ecology is quite complex and multifaceted and multidimensional, so here we're distilling this down here in this particular graph to a question about how often people are visiting natural environments. Now, those could be urban green spaces, they could be wider things in the countryside. They would all count here. What you see is that in much of the world, a very high proportion of people have very, very limited nature interactions. You also see that there's actually a lot of variation amongst countries. So each line of this plot is a different country. We're sampling overall about 23,000 participants. We're focusing here on just 20 to 30-year-olds just to try and narrow down the consequences of relatively limited samples and greater age and demographic complications. The variations here are driven both by country-level factors and individual-level factors. The level of urbanization that you experience, unsurprisingly, has a strongly negative effect on your personalized ecology and on your nature experiences. Your education level tends to have a positive effect, as does your self-assessed social status. And if you cut that experience in different kinds of ways, other kinds of factors around socioeconomics, so forth, also kick in. At the moment, we're trying to actually develop a personalized ecology index that would enable people to self-assess what their personalized ecology, what their direct nature interactions are. Something kind of a bit like a BMI, if you like, and particularly sort of against other people with similar circumstances. Are you richer or poorer in your personalized ecology? Personal ecologies are dynamic. They change by the hour, the minute, the day, the week, season, and they change through your life course. For all of you here, I imagine that, I mean, you are all a bit weird in terms of your personalized ecologies, I'll tell you now. You are not an average sector of the population. On average, you'll have much, much higher personalized ecologies than the population of the globe at large. You are weird. It's always good to be able to stand on a podium and tell people they're weird. You are oddities in that sense. And that makes it hard for us often to relate to what ordinary people's personalized ecologies actually are and how limited they might be. There's also, and this is probably the most important thing to pick up here, is there's also growing evidence for an extinction of experience in increasingly large proportions of the world's population. We recently assembled 100 case studies from the literature, testing whether people's personalized ecologies, whether their nature interactions are declining through time or they're declining through generations. And the answer is yes, that's the commonest pattern you find when you look for evidence of this. It's very widespread. It's stronger amongst those with a greater socioeconomic status, and it affects both your physical interactions and your psychological interactions with nature. It's worth just noting that very few studies have actually been conducted in Africa, and then actually one of the students presenting yesterday had some evidence that bears on this issue. And I'll leave you to talk with him about that. The personalized ecologies are driven by three key processes. They're driven by your capability, by your opportunity, and by your motivation. Your opportunity is essentially the availability and the accessibility of nature to you. Of course, that varies enormously amongst us. It's shaped by the distribution and the abundance of nature in the context in which you find yourself. And what's particularly important are common species in that, because they form many of our interactions. And it's particularly important in urban areas of what's happening to nature in urban areas. This is being profoundly shaped by losses of biodiversity. Just two quick numbers here. There are now about 15 breeding birds per person in the whole of North America. In the UK, that's as low as just over 2 per person. If you reflect upon that, we're now counting biodiversity, big components of biodiversity, in just individuals per person. These numbers are getting really quite small, and they're continuing to decline. Your capability, shaped by your mobility, your sensory abilities, your nature awareness, your consciousness of nature, your ability to detect nature, and your ability to identify it. Most of those things are in decline in many, many populations. And we need to recognize globally aging populations. This is what happens to your hearing as you age. These things are shifting, and that's shifting the nature of people's personalized ecologies. There's bits of nature which become less accessible to an aging population. Your motivation Well, the thing that's being discussed a lot here is what's happening to children and actually reducing nature experiences in much of the world, linked to screen time, number of hours that children are spending on screen, profoundly changing motivations alongside switches in wider society from less physical outdoor labor to more dependence upon technology, a whole array of things shifting people's need to be outdoors and having nature interactions and the opportunities to be outside and having them. Motivation is changing. Climate change seems likely to make these things worse, and that's already been alluded to in this meeting about what happens to the activity of organisms, when they're active during the day, when people are active, how much time people are spending outdoors. In much of the world, it's clear that extinction of experience is going to be accelerated by climate change. Some areas where actually that won't be true, but most commonly it's likely to be the case. What are the consequences of all this? And particularly, what are the consequences in the face of extinction of experience and a loss of nature interactions? I want to pull out just three. The first is the impacts on health and well-being. Lots and lots of studies. Don't worry about the details of this. Is just pulling out one study looking at different aspects of nature interactions, your personal direct nature interactions on your physical health, your psychological health, your social health. Repeatedly, there are hundreds and hundreds of studies now demonstrating that those positive nature interactions, of course there are negative ones which have deleterious impacts on health, but positive nature interactions are really important to your health and well-being. Such things as, and they might also be really important even to childhood development. There's dramatic increases in myopia, for example, in East Asia at the moment. And some researchers argue that one of the causes of that is that people are not out in nature and getting long-distance vision and long-distance views. They're actually spending a lot of time indoors. This plays through into what we're sure you're familiar with as shifting baselines. We pulled together all the case studies we could find on shifting baselines. This is where people readjust what they think is the norm for nature and the norm for environment based on their personal experiences. This occurs incredibly widely. So those sensory experiences reshape what you think is the norm, and that's important from a point of view of conservation because it's what people think we should be aspiring to is shaped quite markedly by their own experiences and what they think is normal and what they think is not. And then you find that, again, multiple studies showing that all sorts of pro-biodiversity, pro-environmental behaviors are shaped by the frequency, the richness of your personal nature interactions. An element of you don't care for what you're not familiar with. The more familiar you are with nature and nature interactions, actually the more likely you are to engage in behaviors that positively influence the future of nature. So it's not hard to see how all this feeds through to concerns about the links between declining personalized ecologies and the future of biodiversity, and how do we bend the curve of biodiversity. At the moment, we're seemingly on this inexorable business-as-usual decline. We at least need to stabilize things and start with. But in much of the world, I come from a country which is incredibly depauperate in biodiversity and nature now, and where actually what we need is to renew, recover, restore, not just protect what's left. And if people are undergoing extinction of experience, shifting baselines, these all offer major societal challenges to achieving those ends, particularly if those things are feeding through to people's attitudes and behavior towards pro-biodiversity, pro-environment policies, actions, behaviors. if we want societal support in much of the world for sustaining the future of biodiversity, we really should be thinking very hard about how we restore people's own personalized ecologies. This touches on all sorts of different realms, which I really don't have a lot of time to talk about today. I think this is a big project we run called Renew, where we're concerned with the consequences of these personalized ecologies for individuals, for communities, for land managers, for businesses. How does this feed through to decisions in the boardroom, for example? And I'd encourage you to go to this website. We've got about 40 different case studies work going on at the moment. Please do go and have a look. The last thing I want to talk about is feedback loops. So some of the consequences of personalized ecologies can then alter the drivers of those personalized ecologies. Feedback loops are all often nasty things, hard to understand, hard to influence. That's very true in the area of personalized ecologies. And the one that concerns us most is something that we call the vicious cycle of biophobia. If people are experiencing extinction of experience and increasing disconnection from nature, and that's fed by discussions in the media, or the lack of positive discussions about nature in the media, for example, how their friends and colleagues talk about nature, declines in their own personal experiences. And you've already got some phobic kind of responses around some bits of nature. These things can start feedback on each other, because then you don't want to engage so much with nature. It gets cast, you become, in growing, I think in bits of Europe, for example, there's growing fear of nature, being out in nature, growing misunderstanding of what nature is about. And so you increase the phobias, which mean you increase the disconnection, which means you increase the lack of support for conservation activities and pro-biodiversity behaviors. And in this particular paper we explore, we think there's a lot of evidence out there that that this vicious cycle, as it is growing and growing quite rapidly. So what can we do about all this? Well, in some sense, lots can be done, and lots can be done very easily. First of all, we need to recognize the positive value of everyday nature experiences. Not just the exceptional ones, not just that amazing thing that you remember for the rest of your life, but actually the everyday. To some extent, the more mundane, the more just normal kind of biodiversity interactions. I've heard mentioned in this meeting concerns about declines in field courses, opportunities to get out into nature. In bits of the world, there are concerns about natural history dropping off school curricula. All these things are things that we could actually relatively readily solve to give people a better grounding in their personalized ecologies, in what a richer personalized ecology might look like. We need to think about nature interactions through architectural design and planning. For many people, the views from their windows are some of the most important nature interactions that they will have on a daily basis. And increasingly, in bits of the world with aging populations, less mobile populations, views from windows are your only nature interaction. So we should think about this as really a core part of building design, urban design, village design, How do we those, not necessarily those kind of deeply immersive experiences all the time, but the ones that as you look out the window, you see nature and not a brick wall. Enhancing personalized ecologies is about the provision and the access to nearby nature spaces. And it's the combination of those two things that's important. For too long, we've thought that just providing people with the opportunity and they will come, and we now know that that's not true. It's actually, access is a more complicated thing than that. It needs to be encouraged, it needs to be designed carefully and thought through carefully. And particularly that's going to be true in an increasingly biophobic world. If people are fearful of nature because they don't understand nature, then the way in which to provide that kind of access will have to change. And the last of these is kind of a plea to you all around, with extinction of experience, transmitting your knowledge and your enthusiasm about nature becomes more and more important. One of the problems with extinction has been breaking, particularly parental children, encouragement, understanding, and so forth. And that kind of places a greater burden on us all to share our understanding and our enthusiasms. Some quick lessons more broadly for conservation. The importance of a people in nature approach, and that's been a theme that I've seen through much of this meeting. That duality is really, really key. If we're going to solve extinction of experience, fortress conservation is not going to help. The recognition that conservation has impacts on people's health and well-being and their attitudes and behavior towards nature, not just on nature itself. Conservation, the recognition that the everyday, as well as the exceptional nature experiences, both matter. And finally, I think we need to reflect upon the fact that the extinction of experience and shifting baselines really are very fundamental challenges for conservation. They're drawing greater distance between much of the discourse that we have here and in meetings like this and in the literature we read and the friends we have and the people we associate, and actually what normal people are experiencing and understanding because of all those consequences of extinction experience for attitudes and behavior and so forth. I like to think that E.O. Wilson would very much have concurred with that final sentiment. Thank you very much.
Thank you. Thank you so much, Kevin. I think some of us in the room are very used to being called the weird ones. We've got time for one question.
First off, thank you. That was flippin' amazing. And also, how would you suggest that everyone in the room, how can we share this vital knowledge of personalized ecology? Like, what would be the best way to do that, to share it with the laymen?
Sorry, just check I hear you correctly. How do people in this room share this kind of understanding? Is that your question?
Yes. How can we share it in an engaging manner with everyday people, not just the scientific community?
I think part of that's just sharing one's enthusiasms and one's knowledge and that in those everyday encounters. And I think in my experience, I live in a little village on a creek, and people are passionate to see many of the organisms that are actually around them, but they would tell me that they're not there. I mean, the level of the gap. And so introducing people to the kind of tips as to kind of, I mean, in my case, it's kind of, you know, everyone's desperate to see a kingfisher. There are kingfishers out there every day, but they don't know what to look for and what. And yet, when you introduce them to those things, they suddenly say, grief, this is amazing. This is the best event of my day or my week or my year. Whatever. And I think sharing those kind of things as well as that broader why nature is important. And one of the challenges we've set ourselves recently, to which we haven't got an answer yet, is, you know, what's the elevator pitch for nature? And conservation's tried lots of different ways of framing that, and we haven't cracked it. But that's part of this same issue. Is, you know, how do I best explain to my neighbors that nature really matters to them in multiple ways? And personalized ecology is one way of doing that because it makes it much more personal. But clearly, it's part of a broader thing of we haven't cracked getting people to understand. I mean, I've sat in so many rooms where essentially nature is just a nicety. You know, there's a bunch of people like you looking after out there somewhere, and if that's good, but you know, what relevance is any of that to me? And we haven't cracked that understanding of that utter dependence of humanity on nature. It's extraordinary as to why that's occurred, but I think a lot of it's about enthusiasm and sharing and recognizing that many people are not seeing the things and that actually they readily could if they knew how.
Cool, thanks, Kevin. Okay. Up next, we have Leanne Kant. And Leanne's going to be talking about changing the conservation narrative.
Thanks, Wendy. Good morning, everyone. My name is Leanne Kant, and I am from the School of Wildlife Conservation at the African Leadership University. And today, we're going to be talking about changing the conservation narrative, aligning conservation and development. What if conservation was not just about pristine landscapes, but about actively generating wealth? What if it was not just about protecting species, but supporting people and livelihoods? This is not a distant dream. This is a necessary reality. In this future, conservation and development are not mutually exclusive. They are not competing forces. They are mutually aligned. And if you have a close look at this picture, which was generated by AI, you will see that there is a capybara, there is elephants walking in the village, and there is a zebra with no face. And this is kind of the perfect metaphor for the conservation landscape. There is no perfect conservation landscape. There are hardly any pristine landscapes left. So instead of trying to find the perfect solution, let's focus on progress instead of perfection. At the School of Wildlife Conservation in 2021, we published a report, The State of the Wildlife Economy. And in this report, we wanted to identify what is the current state of our wildlife economy in Africa? What is its potential, and how do we unlock this potential? And in this report, you will find this map, which provides a very broad overview of the wildlife economy potential in Africa. And this was mapped using weighted species richness, biome richness, and landscape features. And I think it's pretty clear from the colors that the green indicates a high wildlife economy potential, the yellow a medium potential, and the orange a low potential. However, the word wildlife economy has economy in it. And this map does not include any economic indicators. So despite the potential, how do we unlock this potential? And this is where I introduce the Wildlife Economy Investment Index, which was launched at the end of last year. So what is this Wildlife Economy Investment Index? And I might just refer to it as the index so I don't get tongue twisted along the way. So the index is a tool to indicate a country's investment attractiveness or openness within the wildlife economy. Who is it for? It's for investors, NGOs, governments, academics, communities, probably everybody in this room. How was it developed? It was developed through various stakeholder engagements, and it was co-designed with identifying indicators that are specific to the wildlife economy. Just to briefly run through its objectives, of course, we wanted to develop an index related to the wildlife economy. We wanted to create advocacy and awareness around the wildlife economy, provide actionable insights, foster competition and improvement. There might be a country who's not quite happy with their ranking and feels they need to get a bit competitive and push their ranking scores a bit higher. And then data analysis and informed decision making. And if you were here earlier this week, you would have heard my colleague Irene Mashlanga. She made quite a popular quote by Peter Drucker: "You can't manage what you don't measure." We've also since published a methodology report and a results report, and I will briefly run through the methodology. So to get a country's score or ranking, there are 280 indicators that contribute to the overall score. And the score is ranked from 0 to 100. And within this overall score, there are two sub-indices. The first sub-index being the investment enabling environment, which has 220 indicators linked to it. And branching out from this investment enabling environment, you will see that there are categories and subcategories. The second sub-index is the wildlife status sub-index, and you will see there are only 60 indicators here, which is perhaps one of the limitations to this, but also an indication that we lack data in the wildlife economy space. And on that note, I invite anyone to please go have a look at the methodology report, have a look at those indicators, and see if there are any more we can include in the wildlife status. So let's have a look at the results. Let's get to the fun stuff. Any guesses who came first? South Africa. I see Randani, she's heard this a few times. Yes, South Africa came first. So here is a map of the overall scores. SADC was the top 5 countries, with South Africa, Seychelles, Mauritius, Namibia, and Botswana in the top 5. So I think it's quite obvious. The green is the top scoring countries, and those are the upper third, the top 18 countries. The middle scoring countries are the orange, and then the lower 18 are the red countries. We also have 54 country reports, so there is a report for each of these countries. You'll actually see, if you have a look at the map, there's only 53 rankings, and that's because São Tomé and Príncipe did not have enough indicators to be ranked. It had less than 50% of the indicators. So there is a report on it, but it is not ranked. So we've got the investment, or the wildlife economy potential map, and now we've got this investment index. Let's see how the two compare. And to illustrate that, I'm going to show two different countries, Mauritius and the DRC. And if you have a look at the wildlife economy potential map, DRC is highlighted, is green, showing high potential. However, on the investment index, it is red, showing low potential. Mauritius, on the other hand, on the potential map, shows low potential. However, it is green, so it's in the upper third. It actually came third in terms of the Wildlife Economy Investment Index. So just to show their rankings, their overall rankings, Mauritius came third and the DRC came 40th. So the wildlife status. Let's have a look at the two sub-indices to get an idea of how these countries actually achieved their overall score. Wildlife status, you will see aligned with the potential map, DRC has high wildlife status, and Mauritius on the lower end. However, if we have a look at the investment enabling environment, you will see that Mauritius scored first in terms of investment enabling environment, and the DRC in the lower third. So you might be thinking, these are two different countries, two different landscapes, contextually very different. Of course, they're going to score differently overall. But let's have a look at some countries that are perhaps perhaps similar. So sticking along the islands, Mauritius and, I don't have a pointer, so I can't show you, but Mauritius and Comores, both islands, both scored low in terms of potential. However, when it came to the investment, Mauritius is high, Comores is still low. Where would you go on your beach holiday? Mauritius or Comores? I don't think I've met anybody who's gone to Comores for the beach holiday. Let's go over to the DRC. High potential. Next to it, we've got Tanzania, Rwanda. Let's go over to the investment map. DRC low, Tanzania high, Rwanda very small but also high. Where would you go visit gorillas? Rwanda or the DRC? If someone was going on a 10-day hunting safari, would they go to Tanzania or would they go to the DRC? Let's take it away from tourism. Both countries have high fishing potential. Both of these countries, or Tanzania and the DRC, but majority of their fisheries is from inland fishing thanks to the Great Lakes. However, Tanzania is able to export at least 15% of their inland fisheries. DRC is not exporting anything. In fact, they need to import. And because these countries border to a certain extent, I wouldn't be surprised if there's some informal export going on from the DRC side, and don't quote me on this, but perhaps DRC is selling over to Tanzania on an informal market, only for Tanzania at a higher price to sell it back to the DRC. The importance and the value that I'm trying to show you is that despite the potential, if there isn't an investment-enabling environment, what can be done? What can we do? I thought to show the relationship between investment-enabling environment and the wildlife status subindices, I would create this bubble chart. And on the x-axis, we have the investment-enabling subindex score, and on the y-axis, we have the wildlife status subindex. The colors of the bubbles are related to the region, and the size is just there for contextual regions, it's population density. I then thought, let's put this into a matrix and cut it in the 50-50 mark to see where the countries are being placed. And I thought I would aptly name them. First being green prosperity. Green prosperity being high in wildlife status as well as high investment enabling environment. Not too many countries here, unfortunately. The second being constrained but conserved. Constrained having a low investment enabling environment but still a high wildlife status. No countries feature here. The third being wealth over wildlife, and this being a high investment enabling subindex and a low wildlife status subindex score. And I think there's a large majority of the countries feature here, and I think this is not a bad sign because there is at least wealth here. There is at least an investment enabling environment. And if there's investment enabling environment, hopefully we can push the wildlife status into that green prosperity zone. And then the final quadrant is the untapped potential. And I called it the untapped potential because if you have a look at the countries that are quite on the lower end of the quadrant, you will notice that these were actually countries that featured quite a lot in red. And in a lot of these countries, there is not enough research happening in these regions. If I have a listen to the conference over the last 3 days, and we have a look at that map and the countries that are in red, how much of our research is coming from there? I'm sure there are researchers doing some amazing work, but there's definitely room for growth. If we're not sending our researchers to those countries in red, how can we expect investors to invest in those countries? How can we expect tourists to go to those countries? So I refer to them as untapped potential, because if we start directing some of our research efforts, we might see these climb in the wildlife status. Of course, like any index, it has its limitations, and it's important to at least acknowledge these limitations. But also these limitations are not limited to the Wildlife Economy Investment Index, but they're generally an issue among all indexes. The first being reliance on secondary data, the second, potential for biases from the data source, variation in statistical capacity among countries, which I just referred to in terms of where the research is taking place, and the decreasing influence of subcategories or indicators as their numbers increase, and the transformation of categorical data in numeric data, and some assumptions made in the aggregation method. And as I've mentioned, these are not necessarily unique just to this index. There are limitations in many indexes. So to conclude, I have brought you back to this imperfect picture. And instead of trying to create the perfect conservation landscape, the perfect pristine condition, perhaps we should focus on its complexities and its challenges. And instead of thinking of conservation and development as being mutually exclusive, we can see them as being mutually aligned. Thank you. If you would like to download the report, please scan the QR code and we'll take you straight to the index page. Thanks.
Thanks, Leanne.
Thanks.
We have time for one question.
Cool.
From anybody that wants a question?
Thanks for a great presentation, really nice graphics. This is probably something you already thought about and maybe didn't have time to talk about, but I know with indices, that aggregation, what weighting you give to the different categories is so important, and subjective as well. I'm sure there was some disagreement. And looking at Mauritius jump so high up made me think that the investment potential was maybe weighted possibly a bit more heavily than the wildlife assets. But one thing I like to see is a graphic of uncertainty, like what happens if we change the weightings? What happens if we used slightly different indicators? And what you typically find is that certain countries that you measure are less sensitive in their ranking to changing in that weighting. And it's actually interesting to know which countries still come out on top, despite which particular indicators you use, because I'm sure there was lots of disagreement among stakeholders. I just wondered if you did look at uncertainty in rankings related to changing your assumptions, the sensitivity of your rankings to changing those sorts of things. Because often that can actually lead to quite useful information about which countries are robust to that uncertainty. And yeah, you probably thought about that a lot, but I'd just be interested to hear more.
Thanks. So just to put a clause out, we had a statistician and data modeler that worked solely on this. So he would probably be the best person to answer that question, and I don't want to butcher it. But that certainly is something that has been thought about. And if I had to go, I hope I've got time, go back to the number of indicators, you will see here investment enabling environment has 220 and wildlife status has 60. And that means if we look at an indicator like species richness, which only has 2 indicators, that's 50% each contributing to the species richness subcategory, versus business operations, which has 51 indicators, indicating that a single index could have something like a 2% contribution to an overall. So yes, there was certainly a lot of back and forth, and I think that is why we need to look at some more wildlife-related indicators to perhaps push out some of those imbalances that there could potentially be. Thank you for your question. Thanks.
Thanks, Leanne.
Cool.
Before we get to the next speaker, can I just ask Marta to please go and get mic'd up at the back? So next up we have Arthur Tudor. He's going to be talking about developing regional capacity for marine research.
Good morning. Okay. I'll start by introducing myself. My name is Arthur Tudor from the Western Indian Ocean Marine Science Association, WIOMSA. I'll be telling you more about WIOMSA in my presentation. But this morning, I have just about 20-25 minutes to talk about how we've been developing regional capacity in marine science in the Western Indian Ocean region. I know this conference is largely made up of ecologists and wildlife scientists, but I just want to take you a little bit on the other side of things, the marine realm, but looking at really what scientists are doing in the Western Indian Ocean region. All right, I don't know whether I have the, all right, next. Great, so we know that our oceans are very important. The previous presenter just talked about Mauritius, Comoros. That's part of the Western Indian Ocean region. And we know the value of marine ecosystems. And currently, as the world is focusing a lot on the blue economy and harnessing the potential of the ocean to create wealth, the ocean becomes a very important realm or an important space for economies and for livelihoods and for countries globally. And we know that, of course, our Earth is 71% ocean. And it generates big wealth, estimated to be close to 1.5 trillion, in terms of, economic contribution. But our ocean also faces so much threats. As we know, overfishing is a big problem everywhere in the world, Africa especially, illegal, unregulated fisheries, pollution, plastic is killing our oceans. We're going to have more plastic in the ocean than fish by 2050, we're told. Coastal development, we're growing our coastlines like never before. Marine litter, huge problem. Climate change, ocean acidification, all these are issues that we face. And as scientists, these are questions that we ask ourselves every time. How are these things going to be resolved? And so we have an imagined ocean that we want by 2030, according to the UN Decade of Ocean Science. We want a clean ocean, a healthy ocean, productive ocean, safe, accessible, predicted, all nice things that we want to see by 2030. So under the UN Decade of Ocean Science, we have this ambition that by 2030, we shall have improved our oceans so much through science that some of these threats will obviously be reduced. But what is this science that we need for the ocean that we want? And that's a question that we're asking ourselves. Are we doing the right science? Is this science going to drive change? What is the science that we need for this ocean that we want? So WIOMSA is an organization that supports marine regional science. But one of the things that we see across the world is the low level of investments in marine science. In Africa, for example, the gross domestic expenditure on research and development that is allocated to marine research is less than 0.1%. And of all the countries in Africa, it's only South Africa probably that invests around 0.1% in marine research. So the rest of Africa, investment in marine research is almost zero. Yet, we're talking about the blue economy, the ocean economy, and dealing with all these threats. So this is where part of our problem begins. And as WIOMSA, we've been trying to support marine science and building marine research capacity in the Western Indian Ocean region now for 30 years, knowing very well that one of the issues facing Africa and our region is low funding for marine research. So unlike terrestrial research on wildlife, on elephants, on rhinos, which has been receiving so much attention in the last 50 years, the marine side of things is quiet. Sometimes we forget that we have wildlife in the ocean. How many marine ecologists are seated here today? You can see how threatened we are. We are very few. We are almost an endangered species. So hopefully next time we'll have more marine scientists also presenting here. So who is WIOMSA? So the Western Indian Ocean Marine Science Association was started as a small association of scientists, about 12 of them, way back in 1993, to come together and support regional marine science in an area that is called the Western Indian Ocean region. Last year, we marked our 30th anniversary, so we've been around for a long time. But I'm not sure how many of you have heard about the Western Indian Ocean Marine Science Association. So the association covers 10 countries. So basically, we support marine science in 10 countries. Somalia, all the way to South Africa. Okay? And it's that blue region that we call the Western Indian Ocean. And our aim is to foster regional collaboration across all areas of coastal and marine sciences and management that support sustainable development. And of course, key is that we want interdisciplinary and multidisciplinary approaches, meaning that we want to integrate all the sciences that are relevant for the ocean so that we promote sustainable development. So that is who WIOMSA is, and that's what we do. And it's a membership organization of scientists who started way back in 1993 as a small group of scientists, you can see from that photo, to now close to about 1,200 scientists who are members of the association. And these are scientists that are drawn from the region, but also from other parts of the world. So it has grown over time. And so now I want to share with you what has this growth contributed to marine research in the Western Indian Ocean region. So WIOMSA supports science through grants. We give out marine research grants. And we have two types of grants. The first one is the Marine Science for Management grant that helps scientists from all the 10 countries to come together, identify key research areas that they're going to study for some time. Usually the grant covers up to 3 years, and it's awarded up to $400,000 for 3 years. We also have the Marine Research Grant, which is meant for the early career scientists, those who are doing their PhDs and masters. And our grants cover many aspects, supporting scientists' times at the institutions, purchase of equipment, building infrastructure, publishing, and facilities that support marine research. The overall aim is to strengthen the knowledge base in marine research, promote interdisciplinary and multidisciplinary research programs, but also build capacity for marine research in the region. In Africa, we have very low capacity when it comes to the number of marine scientists that we have. So WIOMSA over the years has helped to establish a sizable number of scientists through our grant programs. And so after 30 years, so what impact have we had? And that's what I want to really present in terms of results, because we give funding for research that is used for undertaking research activities, and then we have research outputs. A lot of times, funding organizations don't measure the outputs or impacts of their funding programs. And so today I want to focus on the outputs, but I know very well that it's more important to focus on the impact. What has the research contributed to in terms of new ideas, new knowledge, policies, and things like that? But that is a more complicated type of analysis, so I want to focus more on the output as an indicator of the impact of our two research grant programs, the MAG and the MASMA. And we do this at WIOMSA because we want to measure how knowledge has grown in terms of production of marine scientific publications, but also the impact of grant programs so that we can report back to our main donors, and also for reporting to stakeholders and other scientists. So we conduct this review to be able to even design new programs, but also change the trajectory of our funding programs if need be. So some quick results, but that before I get there. So the research that we did, or the analysis that we did, followed what you'd call a bibliometric analysis, which is basically a statistical analysis of books, articles, and publications that have been produced from our grant programs. And this can follow two parts. You can either do a performance analysis that looks at the measurements and classifications of publications, or you can follow the science mapping, which looks at visualized interaction among scientists, but also analyzing other factors that can be measured, like impact factor of publications, co-authorship, and things like that. So these are the kind of analysis that we've done to be able to demonstrate the impact of our grant program. I'll stop there. So we looked at all the products or publications that have been produced by our scientists from the two grants. And we were able to, up to this year, count 628 scientific publications, which can be classified as journal articles, close to about 500 journal articles. We may have missed some because we are only looking for articles that acknowledge WIOMSA, the MASMA, and the Midrand. So it's possible that some were left out because the authors did not acknowledge the funder, or maybe there was co-funding and WIOMSA was not mentioned. But up to last year, we were able to generate 499 scientific publications, 72 technical reports that are of regional importance, like State of the Ocean reports for the Western Indian Ocean region, and other reports that are important for regional ocean science. We supported PhD students who produced 36 theses, which we also consider to be very important scientific publication, and 21 books. So in terms of science productivity, our grants have been able to produce that kind of result. And the trend is that these publications are continuing to grow. So as you can see from the graph, it started from very few publications up to around 2020, 2021, thereabout, we see an increase of the number of publications. And because we've added more funding the last few years, we hope that by 2030, this number should probably get up to 1,000 publications. And you can also see the distribution of publications across the years, and you see at the beginning there was emphasis on reports and things like that, but over time scientists have begun to publish on high-impact journals and also start focusing on publishing books, which is something that is often very rare in Africa, to find our scientists publishing books. A lot of the books that we read on any science or ecology are often published by external scientists who probably come to work in Africa and produce books. But these publications were specifically generated by our scientists from the Western Indian Ocean region. And countries have got different capacities in terms of marine research and the outputs that they produce from the grants that we give. So you can see from this graph is that some countries obviously produce more than others. So these are studies that have been done specifically in those countries. But we also have studies that have been done in the region that cover multiple countries. So if you see where there's WIO, that's Southwest Indian Ocean. WIO is the Western Indian Ocean, but the countries represent individual sites where these studies have been conducted and produced. So Kenya has been leading, followed by Tanzania, Mozambique. South Africa has more publications, and you may wonder why it's small, because in the Western Indian Ocean, South Africa is only considered halfway up to the Cape, going back that way, and not this other side. So we work with scientists on the Western Indian Ocean side. And countries have also been contributing differently. So you can see Tanzania, Kenya, and the WIO obviously have produced more of the journal articles. And this also demonstrates the differences in capacity of countries in terms of the number of scientists, the number of research institutions, and also, generally things that affect science productivity. So some countries have got more individual scientists, experts in some fields. Others are fewer than, of course, comparatively. And WIOMSA's objective is actually now to work with countries like Comoros, Madagascar, the smaller countries, to be able to bring them up to the level of other countries like Kenya. And that's just another way to look at the distribution of scientific outputs across the region. The challenge has been with Somalia, where for a long time there's been political instability, and only recently have they begun to engage with us more closely. So our focus now is going towards Somalia to see how we can enhance research capacity in that region. And so which topics are covered by all these grants? They vary from fisheries all the way to marine geology and geophysics. But you can see that within the Western Indian Ocean region, there's a very strong fisheries research group compared to other areas of research like climate change, and marine technology, and these other fields. So as WIOMSA now, after this analysis, we are changing our program and grant programs to be able to now to focus on areas that are least studied. So our grants sometimes are designed to be able to create interest in these underdeveloped fields of study. But fisheries, obviously, is one of the main areas where we have a huge number of scientists. And that is also true because we also look at the number of institutions that offer training in fisheries. and aquaculture, they're more than those that offer trainings on marine robotics, marine engineering, and stuff like that. So this is just another way of looking at how the publications are distributed, and you can see fisheries management, science, biodiversity, ecology are the top in terms of number of publications, with very few in ocean governance. I'm sure even wildlife governance, terrestrial wildlife governance is not, we don't have a lot of research in that area. Reef studies, coral reef studies, geophysics, ocean acidification and climate change. So these are new areas of research that we want to promote as WIOMSA. And who publishes, really? So the academic community is the top in terms of the number of publications. So these are universities in the region, followed by research centers, which could be led by government or NGOs. Research institutes like ORI, Oceanographic Institute Research, that are led by government, Kenya Marine and Fisheries. Government agencies, surprisingly, also do research. NGOs, intergovernmental authorities like the UNEP, the Nairobi Convention, the local government, this is local government agencies, and there's national government, and others. So our grant really is meant for scientists, but it also encourages co-design, meaning that we encourage our scientists not just to work together as scientists, but also to involve governments, to involve NGOs, to involve communities, and also work with them in terms of publishing their work. So this is something that WIOMSA has been promoting over the years. And that's why you can see it's not just from the academia, but even governments are able to participate in producing science. And so this group of scientists that started in 1993 as a small group of scientists, how has that grown in terms of relationships? So we mapped out the networks of scientists through co-authorship between 1995 and 2005, and you can see that 20 years ago, it was a small network of scientists, not very well connected, probably just getting to know each other. 2006 to 2015, we see the networks strengthening and growing stronger. And then 2016 up to 2024, you can visualize how the network has grown. So meaning that funding collaborative research actually encourages scientists to continue working together and collaborating in producing research. And that's something that is good to see in programs like MASMA and WIOMSA that were designed with the intention of promoting scientific collaboration. And that's how the network looks now, like after 30 years. And all those nodes represent individual scientists. So it's a big group of scientists in the region who connect through exchange of information and knowledge. So we looked at the networks, some of the network attributes, to be able to determine if there are significant changes or differences across the 30 years. You can see the number of scientists rose from 56 to 571 to 965 to 1455. That is the number of scientists involved in publication over that period. And so what are our key findings? The key findings are that the network has significantly expanded in terms of both nodes and edges, meaning the number of scientists and their connections, particularly between 2006 and 2015. And this suggests increase in collaboration or interaction among the network participants. Diminishing density, meaning that before the networks were so centralized, they were focused on a few scientists, but as the networks grow, the central actors are becoming fewer and fewer, meaning there's more new central actors or scientists coming on board. And the strength of connectivity among scientists is actually stabilizing, it's growing, so we're seeing more undirected connections between scientists and exchange of scientific information. So meaning as the network grows, the bonds are actually strengthening. And increased weight interaction also looks at the strength of exchange of information between scientists. And this also reflects that the networks are actually enhancing flow and exchange of information. And as I said, the centrality of the networks is shifting, meaning that we're seeing more and more central scientists coming up, and not like previously, where a few scientists do dominate the network. But an important finding is also that in as much as we fund research in 10 countries, this work has brought in other countries. So we're seeing collaboration across the world, beyond the West Indian Ocean region. And 39 countries have been part of this scientific process, contributing research or publishing with our scientists from the region. So one of the key outcomes is that it has promoted even the North-South partnership in research. We're seeing a lot of scientists from Sweden, from the UK, from Germany, working with scientists from our region. And how do we communicate this science? As WIOMSA, we've developed a number of tools to communicate this science. We have the Journal of Marine Science, the Western Indian Ocean Journal of Marine Science. We have scientific magazines that we produce for these publications. We produce a science policy communication that we call the WIO Science Policy Platform. We hold our symposiums regularly. Next year, we are holding our 13th scientific symposium in Kenya. Last year, it was in Port Elizabeth in South Africa. So these are the different ways where our scientists come to share their knowledge and also communicate their findings. So as I said, our scientific symposium is one platform just like this, where we meet after every 3 years to share our scientific findings and also to collaborate in new ways. But more importantly, WIOMSA also promotes the participation of women in science. So we have within WIOMSA a network of women in science. And from these publications now we are analyzing what has been the contribution of women in science in the region. And I don't have those results. Probably in the next presentation I'll be able to do that. We also support the Early Career Science Network in the region, the WIO-ECN. So the grant, MAC grant, is specifically designed to support early career scientists. But we also work with practitioners. So how do we ensure that this science is utilized? We work with protected area managers under the Western Indian Ocean Marine Protected Area Network. There is a network of marine protected area managers who benefit from this scientific program. So WIOMSA is a network of scientists, but within WIOMSA there's Women in Science, Early Career Science Network, and Western Indian Ocean Marine Protected Area Network. So it's an integrated community of scientists and practitioners and knowledge users. So moving forward, what is our plan as WIOMSA? We have several decade ambitions, the decade of ocean science, that by 2030 we should have good science that is going to support management of our oceans. We have the SDG goals by 2030, zero poverty, and many other goals. We have the global biodiversity framework that by 2030 we must protect 30% of our oceans. So there's a lot of work that still needs to be done by scientists. There's more resources that are required to support these global ambitions. And as WIOMSA, we are redirecting and reorganizing our programs for research to be able to support these global ambitions this decade and beyond. But also there's the blue economy that Africa is promoting as the next frontier for economic growth. We must begin looking at research that has more direct economic impact. And that is what governments are asking for. So how do we as researchers contribute to a sustainable blue growth? We must refocus and think of our research in different ways. So WIOMSA is working with governments and stakeholders in the region to be able to prioritize some of the knowledge areas that will drive the blue economy. So we've introduced a new grant called the Science Policy Grant that now helps to translate all this scientific knowledge that has been generated into policy for blue economy. So we give grants now to not to go back to the field and collect more data, but to use the data that you have and make sense out of it and share it with governments. And also promoting innovative action. So some of the grants we give to actually convert those scientific findings into real outputs. So we have the innovation grant that we are introducing to be able to support innovative actions like this was one of the research outcomes that is being supported. Finally, we still have a challenge. We have a growing number of early career scientists in the region. Out of the 1,200 members of WIOMSA, nearly 600 to 700 are young people who have just finished masters or starting their masters or a PhD. So we have a huge human capacity for research. And you can see from the applications that we receive for the grants, they're ever increasing. but the resources are always dwindling as the numbers increase. So that's our big challenge now. How do we support this growing mass of young scientists and keep them within this field so that we don't lose them and encourage them to take over from the older generation? But finally, I want to say that investing in science produces good results. A lot of times we're challenged as researchers to say why we need money for research. But WIOMSA has been able to demonstrate that more funding leads to more research output. How we use that output is another thing, but research needs to be funded to produce good scientific output, and that's what WIOMSA is focusing on. And I want to say thank you very much for listening.
Thanks, Arthur. Any questions, suggestions, complaints? Okay, well, I'm sure you can catch Arthur throughout the day. I'm sure there's many youngsters just dying to prevent marine scientists from going to extinction. Thank you, Arthur. Up next, we are taking a trip back to the Kalahari with Martin Mansa, talking about animal vocalizations and the implications for understanding group dynamics.
Good morning, everybody. Thank you very much for giving the opportunity to talk a little about our research on vocalizations in animals. And today is really just to show you how much information there is in the call and the potential for conservation and management. And this is mainly based on research we have done on the meerkats up in the Kalahari. Many of us probably have, in the last few years, used apps like iNaturalist to take pictures of an animal that we couldn't identify and immediately got a suggestion of the name of the species. In a similar way, we also have the Merlin, the bird ID, that records the vocalization of a bird and gives us the species. So we more or less know a species is present or not present in a certain location. But I would like to argue and show today, in an animal vocalization, there is much more to learn than just present yes or no. And I've also learned yesterday on the wild track, we can also do this in tracks of animals. So we can learn about age of an individual, potentially about the social status of individuals, and this is more or less what I would like to show you today. In animal vocalizations, we have a huge variation. We have very acoustic, distinct calls or units. Some of the calls are graded into each other. Animals produce sequences of calls or combinations, and we also have a huge variation in call rate. And this is all functional and gives information to receivers, and there is a lot of research how strategic this is used by the producer. Already 50 years ago, people have suggested that the acoustic structure gives a lot of information to the receiver. Calls that show a rather tonal structure indicate most likely fear and that an individual is going to retreat, versus calls with a harsh, noisy structure probably indicate the producer is dangerous and may attacking us. And I've, together with my research group over almost the last 3 decades, studied animal vocalizations on the different mongoose species, in particular focusing on the meerkats up in the Kalahari, going along with the big project up there. So what we've done is recorded the calls of meerkats. Meerkats are habituated that allow us to go very close to them, and we then play these calls back from a small loudspeaker and test how the individuals respond. This allows us to really identify what's the function of a call, what do the receivers understand from the call. However, we not only go out with a microphone, we have developed new techniques where we put in small microphone, GPS and accelerometer into a collar and put it on each group members in a group. And this allows us really to record all the vocalizations of the individuals, but also see the position related of the group members to each other. And this is an animation of the recordings. On one hand, the location of the individuals in relation to each other. On the other hand, what type of calls they emit during this time. And each dot represents a group member. For example, the red dot means it's the dominant female, the yellow dot means it's the dominant male, and the others are subordinate individuals in this group. Then we have below the symbols for the different vocalization types. If you see a circle flashing up, that means they give a contact calls, the most frequent calls given during foraging. If you see a red star, it means there is an alarm call, and I will show you what's going to happen. So if we follow this group of meerkats, you see one of them is slightly separated from the group, while the others are all close together, dominant female and red. More often at the edge of the group, you see the contact calls flashing up, and so we can really understand what the whole group does in relation to the other group members. And you now see this blue individual being separated from the group, the rest is foraging. This blue individual is a sentinel, gave an alarm call, and the whole group rushes over to this individual. And this continues and allows us to really ask specific questions and put up hypotheses. Who in the group is leading? Who is doing most sentinel, has the biggest influence on other group members to really join a group. So this really, the research over the last almost 30 years has allowed us to identify the vocal repertoire of meerkats and probably about 30 different call types in these species, which are related to very specific behaviors. And I tried to give you a little insight on how these calls sound like. It's the contact call, lead call, contact call, terrestrial alarm call, and the sentinel call announcing everything is fine, nothing to worry. So I hope you got the impression we have very distinct different call types, and this allows even us observers to really say what's happening in the group. The most famous calls, and this really has more or less made my early career, are the alarm calls in meerkats, where we have distinct alarm calls, different alarm calls given to aerial predators versus terrestrial predators or snakes, and the receivers respond accordingly different. This is an example of a terrestrial alarm call given to a predator quite far away, and the following call is given to a terrestrial predator close by. So these are very distinct calls, but in fact these calls can grade into each other. Yeah? The acoustic structure goes along a continuum. And we have the same for aerial predators and for the recruitment to snakes or tracks, smells of other predators. So in these alarm calls we have distinct information on the predator type, but also on the risk, on the urgency of the situation. We also have information about the individuality of a call. Here, for example, close calls, the most frequent given call while the group is foraging, every few seconds, individuals give these calls. We have variation in these calls on the fundamental frequency, but we also have variation of these calls in the duration. And I'll play you the calls of 10 different individuals. So if you're very good and spend some time with the meerkats, you will be able to hear how this must be this individual or that one in particular, distinct calls from the dominant individuals. We have another level where individuals show variation depending on age. Pups show a different vocal repertoire to adults. Pups mainly are begging for food, so they have a totally different function, but also within adults, dominant individuals, in particular the dominant females, give much more aggression calls or lead calls than the subordinate individuals, and subordinates are the only ones that give submission calls. So looking at all these variation in the acoustic structure, but also who is giving which specific call type, really allows us, just from hearing, a little what's going on out in the group, and we can relate the specific call types to the general context, external object with the functionally referential alarm calls, but also get information about the internal state, motivation, or emotions of the call. And as I pointed out, individuality plays a big role, including also age and status. Now you may say you can do this all on the meerkats, but in fact the collaborators on these collars, Ariana Strandberg-Pöschkin and her team, they also put on these collars on a clan of hyenas to track the distribution of the social group. They've done this on the K. Holekamp project in Kenya, where they colored 19 hyenas, and you can see here the different colors indicate the different rank of these individuals in the group and how they are moving over the time. They have put on these colors about a month and more or less can now reconstruct their movement. Taking out a very specific event on a long distance recruitment, which lasted about for an hour. I'm going to show you here the movement of these individuals. We see on the top a few individuals that all seem to run down to that specific individual, on the bottom, the brown individual on the group. And people have not exactly been there, but what they afterwards did, analyzing the calls, in particular the long distance recruitment calls, and the first individual to call was that individual on the bottom. It emitted at the reference point 0 long distance call, sorry, the call didn't come through. And this induced that other individuals would walk towards that individual, but at the same time emit these same call types as well. And most of the group members then came together to that individual that started to recruit, but a few individuals didn't show any response. And this really brings up questions. Why did those individuals not respond? Is it because they were too far away? Is it because they are not as closely related to the caller, etc.? So this allows us to indicate or come up with new hypotheses and do tests. However, instead of putting on collars, one could also have put out an array of microphones, and we would have recorded quite a lot of information just by this non-invasive technique. We would have detected the first individual that would have called on the bottom, and then who else would respond, and we probably would also have detected who of the individuals had moved, as later on they give a different call type at that location. And using such microphone arrays is done in quite a lot of areas nowadays. Soundscape monitoring has become a popular technique. We have put up at our Kalahari research site about 80 camera traps in the different areas that we are monitoring at the moment. And at the moment we are discussing to potentially also put up microphones and monitor the animals. This would not only allow us the meerkats to monitor, but also other species and the potential interactions. So I would like to point out that recordings of animal vocalization, this is much more than just saying a species is there, but we can use acoustic monitoring, whether it's arrays of microphones or putting a microphone at a specific location, for example, a breeding burrow or a burrow where we know that a group of individuals is gathering. It allows us to identify from calls the species is there, but potentially also the movement patterns. It allows us whether there are young individuals there, a recruitment rate, infant versus adult vocalizations, but gives us also information about the structure of populations, dominance, who is leading, territoriality, but also state of population, how cohesive, how cooperative these individuals are, and potentially also how hungry or disease, and this is something we also would like to look into. And finally, we also can pick up on interspecies interactions. Challenges on this is we produce a huge amount of data to really be able to handle that and analyze it, and of course to identify automatically the call types, and this information in calls has to be developed for each species by itself. So a huge challenge, but help with artificial intelligence. With this, I would like to acknowledge a huge number of people that obviously helped our research up there in the Kalahari, and then also thank you for your attention. And anybody interested in the Soundscape project, welcome to talk to me. Thank you.
Thanks, Marta. Unfortunately, we have no time for questions, but as Marta says, if you'd like to vocalize with her during tea, I'm sure she'll vocalize back. Next up, we have Morgan Hauptfleisch, that's talking about a mammal slightly larger than a meerkat. He'll be talking about elephant movements as a driver of landscape conservation.
Good morning. Thanks for making it, really. If I sound a bit daunted, in Namibia, the population in this room is equivalent to the medium-sized town, so if you've ever been. So I'm going to talk about take you through a bit of a journey of the hypothesis that we're coming up with for work that we're going to be doing in Namibia over the coming few years. And this is made possible by the Oppenheimer Generations Research Fellowship, which we are calling the Fellowship in People and Wildlife over the next 6 years. So let's go into Namibia. Let's go into a finer scale. It's been incredible at this conference to look at. We're looking from a global scale right down to what a meerkat is doing. And I always tell our students that it's a skill to be able to see the big picture, but then to focus down onto a smaller ecosystem. So we're going to focus a little bit, for those who've been to Namibia, we're going to go to the area around Etosha National Park. You can see the salt pan in the top right-hand corner. And I think what's really interesting about arid systems, well, all systems do that, but particularly arid systems. You can see the pan in the top right corner. And this is just your primary plant productivity, an index of that. And these systems breathe, or all systems breathe. In Namibia, they breathe really fast. They breathe in quite shallowly and out quite deeply. And this is what an ecosystem does. It breathes in and out. At the moment, we're holding our breaths for a really long drought and hoping that the rains will be coming shortly. It's one of the worst droughts in history, which has a bad side and a good side, if I carry on. So what is the response of your large herbivores in a desert system to this breathing in and out, to these extreme drought cycles? And that's movement. Now, they're probably not moving as fast as what they are in this picture, but the animals need to move to survive. And in that previous image where we looked at the Etosha system breathing, in the middle of that is a fence. Now, Etosha is one of Namibia's last remaining fortress conservation areas. And it's an interesting system that looks like it is changing at the moment. So, if we look at the study area where we'll be working, or where we already are working and continue to work, you can see the national park in the middle in green. To the west of that, you will see the blue. These are the communal conservancy areas, so that's large open areas of the old Kahuka and Damraland. And then to the south of the national park are your individual livestock farms. Livestock farms and resettlement farms in different colors. There's 1 or 2 private reserves, there's hunting farms, but predominantly livestock. And we're taking advantage of a system. So for human-wildlife conflict early warning, the Namibian Ministry of Environment put collars onto elephants for early warning for villages or farms when elephants go into their properties. So I have a student who's helped develop geofences in these areas, so when the elephant crosses from one farm to the next, the farmer gets an alert. Now, the Namibian, these Kamanyap farmers, I was at a meeting where we presented the system, and the farmers get an alert when the elephant crosses onto his farm. And one of the farmers' comments to me was, "Well, Butchie, that's really clever. But can't you just, when that elephant crosses your geofence, make it disappear, please? Then I'll be impressed with what you're doing." But we've been using these, and I'm only going to use a small data set of the movement of 8 herds of elephants over a period of 1 year. And in that system, this just shows, this is not separating the herds, this just shows you the area. And what we can see from this is that these elephants are not staying within one land use type. They're moving throughout the different land use types. And that we find really interesting, and we are going to look at that system a little bit more. So as a very, very basic, for the movement ecologists, please don't throw rocks at me that I've used the basic MCP to look at the home ranges of these elephants. But it's clear that the elephants are not just moving out and moving back. They are using home ranges right across these different land uses. So they're not really seeing the boundaries between a communal conservancy, commercial farmland, park, whatever it might be. And most of these elephants have been using them. If we look at the proportions, so this is just the proportion of the home ranges within the different land uses for these 8, and these were herd matriarchs of different sizes across these landscapes. And what you'll be able to see is that most of these are utilizing, as part of their home range, multiple land uses. And these land uses have different policy environments, they have different economic processes, but fairly similar ecological systems, or part of a greater similar arid ecological system. There's one particular animal, the third to last one there, 4788, that has its home range only on commercial farmland. And what's interesting about that animal is, if we look at that, she crossed fences, so she breached fences just over 600 times. So in 1 year, these 8 herds of elephants broke fences 1,300 times in 1 year. So if you're a farmer, these elephants are not very popular. But we are noticing a really, really interesting phenomenon in this area, which over the next 6 years we will be looking to understand. And hopefully next year already, there could be one of my students standing up here presenting some of the results in the puzzle, the economic, the social, the psychological, the ecological process that goes around that. You'll also see that one particular animal, the one at the bottom that has a name, Sarah, crossed between commercial and parkland, and most of that was also crossing the veterinary cordon fence in Namibia. So the veterinary rules, and I think disease surveillance, if there's anyone in the veterinary industry, is something interesting that we'll be working with over time. I'm only going to show one graph, and it's going to be very simple. If we look at the home ranges of these animals, so the graph on the right-hand side, you'll notice that the animal that's using commercial farmlands has the smallest home range, but she's one of the animals that moves the most. So that's really interesting because she's bounded, or not bounded, she has fences that limit her movement. But she's moving a lot. Why is that? Is it because there's hassling being happened by the farmers in that area? Is there pacing up and down along fences to be able to breach these fences to reach the resources that she should be able to reach? Then the animals that were on totally unimpeded areas in the in the communal conservancies to the west of Etosha National Park were the ones that had larger home ranges and moved sort of medium distances. So what are the consequences of all these movements of the elephants? Conflict is one of the major issues at the moment, and it's even in the South African media, looking at human-wildlife conflict consequences. And this is one of the effects of this movement which is caused by an ecological process. Interestingly enough, in the media, so the farmers in the area, we interact with them a lot, and they say, the elephants, you've been conserving these elephants for years and years and years, now there are too many, and they're coming out of the national parks, and they're coming into our commercial farmlands, they've never been here before, we farm very happily, take them away. However, what's really interesting is I found there's a wonderful book of Captain James Shortreach of the mammals of Southwest Africa in 1934. So if you look at the current area that we are studying with the circle with the green, and you look at the distribution of animals that Captain Shortreach depicted as the distribution of elephants. Elephants were in this environment. They were in this environment before the fences, before this was converted into farmland. What's really interesting about this book, every individual book of Captain Shortreach, he's marked the distributions one by one. Publishing in those days was slightly different. It's difficult to get hold of a copy of the book. So, one of the big questions around this landscape conservation area, the system that we're working in, with that big breathing out and a long pause between breathing in and causing larger areas for any sort of economic benefit, any sort of ecological benefit, is causing farmers in this greater area to consider, well, can we look at this idea of landscape conservation? Can we try and join our farms together? And I've been in rooms where we're really debating about, can we remove fences between farms, and what would the agreement be between farmers? It's a very difficult sort of policy environment. In the meantime, the elephants have decided what to do. Remember, 1,300 fence breaches over 1 year. So if you look at this elephant here, and pardon the bounding boxes around it, hopefully this is a project we can look at in future about the smart gates that we're developing for elephant movements, but let me not go further than that. Now, this exact area, this animal is walking between commercial farmland south of Etosha National Park into Etosha National Park. So you can see the fence there. We put a camera slightly lower in exactly the same place, pointing a little bit more in the direction of the park. And we found in 1 month, October 2019, that there were 13,000 movements of other animals through that same area. And I'm shortening a little time lapse, which tells the story quite nicely. Fixing the fence. Fence halfway down. That's the following day. You can see the animals trying to move through. And then the decision makers. Look, having a little feed. There we go, right on the fence line. And the cycle continues. So those elephants, 3 days later, opening up the landscape again. And the system continues. So those are our decision makers in the end. With very little time, I'd like to just explain what's happening. So if you look at the national park in the north, you would have a commercial farm, and then you would have a tourism or a hunting farm right next to it. So just a division between them. So those are fences. If you look at the commercial livestock farm, if that elephant decides I'm going this side of the fence, immediately it starts costing. So this asset that used to be worth about $40,000, that individual elephant as a tourism asset in the park, becomes a cost of about $300,000 and one bullet or relocation of getting the animal out, but then you saw in that time lapse about the animal coming back in. Therefore, there's no tolerance towards the wildlife moving out of the park, this breathing system. And therefore, there's no chance of the range expansion happening of a landscape level conservation. If that animal just goes slightly to this side and crosses the fence, it immediately increases in asset value. I'm not sure which assets do that. If they cross a line, they immediately change in their value. So it's worth money then in terms of tourism, but also in terms of hunting value. Obviously, if a population crosses, if a population establishes, what do we say, about 4% of a male population is generally trophy huntable, there's an opportunity to occasionally trophy hunt the animals. But what that does, it increases the tolerance of having these animals on the property. My final slide, with my time being up. If you look at these elephant movements, so the dots on the map are where the elephants are moving. And we're seeing the decision-making by the elephants changing the decision-making of farmers, converting from cattle farming in really, really marginal, difficult cattle area into wildlife. And it's interesting that you see that, in a sense, this is corresponding with the elephant movements across that farmland. And this is an area south of Etosha, around about 1 million hectares. So what we'll be doing in the study is looking at the animal and the human decision-making in this dynamic system, with climate change having more of the dynamics happening. And then secondly, looking at what the obstacles are to larger landscape level conservation, because there's a very fast flip that's happening in that system, which we find really interesting. That not even looking at the communal conservancies. And in the end, our entire study, can we add 1 million hectares to Etosha National Park within the next 20 years? I thank you.
Thanks, Morgan. Unfortunately, we don't have time for questions. If you are sitting on the fence about talking to Morgan during the tea break, take inspiration from the elephants and do it anyway. All right, up next we've got Nonkululeko Pepu, and she'll be talking about the overlap of protected and conservation areas with centers of Bryophyte endemism.
Good morning, ladies and gentlemen. Wow, what a good transition for huge animals to tiny little plants that we often overlook because of their tiny size, the mosses. We call them mosses. But in fact, they are part of a larger group called bryophytes. So we have hornworts, so they are flat on the surface, and then they have horns. That's why we call them hornworts. Then we have leafy liverworts and also thallus liverworts. So the liverworts are branching into two: thallus, the one that you see on the screen, and leafy liverworts. Then the bryophytes evolved again, and now we have the mosses, which are the ones that recently evolved. These are non-vascular plants, which means they don't have the conducting a tissue for water. So what they do is that they absorb water from the atmosphere. That's why we find them in moist and humid areas. And they are very sensitive to the environment. That's why they are usually used as bioindicators of the health of the ecosystem, because they respond first when there's a change in climate, for example, when the temperature changes, and also when the moisture changes. So we can say they are the Jack Russells of the ecosystem. Although they are delicate and small and also sensitive, they are resilient. Okay? So they also act as sponges. They absorb moisture when it rains, and then they use it gradually when it's dry, and also release it to the environment to keep the streams going. They are also interesting because they can be completely dry when there's no moisture, and they can remain dry for years. But once you rehydrate them, they can be revived. Bryophytes don't have roots. What they have is rhizoids. They use those rhizoids to attach to the substrates. And they can grow on soil, rock, dead wood, man-made structures, and also on tree barks, and also they can also be epiphytes. They are used by invertebrates and also some birds for nesting and also for food. They are involved in carbon and nutrient cycling, especially in the forest, and also they have a symbiotic relationship with fungi. The threats to bryophytes are habitat fragmentation, destruction, and loss. And these are caused by a variety of factors, including afforestation, pollution in our rivers, water catchments, and the streams, and also climate change. So if you look at that picture, over there you can see we have the forest, and also we have afforestation on my left. So in a forest ecosystem, the bryophytes have 5 substrates that they can occupy. It's the soil, it's the humus, it's the dead wood, it's the tree bark, and also the leaves of the trees. So if we destroy our forest, which means we are losing all the species that grow in those substrates. Some bryophytes are specialized, they grow on specific substrates, and some can grow on a variety of substrates. So when plants of South Africa were evaluated for the red list, the Bryophytes were not included because of lack of data. But Van Rooy and colleagues in 2019, they identified 50 species in sub-Saharan Africa and the East African islands to be those species to be included in the red list. And of these 50 species, 18 occur in the flora of Southern Africa, 15 occur in South Africa, and 7 are restricted in the Cape, in the fynbos. So what we did is that we took data on the endemic species, and then we overlaid our centers of Bryophyte endemism on the officially protected areas as well as officially the official conservation areas. Ladies and gentlemen, these are the results that we got. So as you can see that in the central plateau of the region, there is not much information, there's not much data. This is because of collection bias, and also we are one of the threatened group of scientists. How many biologists do we have in the room? Only biologists, 1, 2? We have 1 and 2, ma'am? Or we have only 1. So it's just the 2 of us. So in Africa, we don't have more than 10 biologists in the whole continent. So we are a rare species, and we need to work very hard, Dr. Malin. So what we proposed 5 centers of Bryophyte endemism. The first one is Southwestern Cape, which is our main center, and we have Kamisberg sub-center of endemism and Zetterberg sub-center of endemism. They are situated, the laser doesn't work. They are situated in the southwestern Cape of the region. Then we have Oteniqua, and also we have the Drakensberg sub-center of endemism. So when you look at the conservation areas, this is what we got. So 4 of our centers correspond with the conservation areas. Then when we look at the protected areas, all 4 centers of endemism correspond with the protected areas, officially protected areas. And also, the farms contributed a lot in the conservation. They act as corridors, and also they harbor a lot of conservation areas. So in our database, we also have all the localities that have the endemic bryophytes. Now let's look at the biofloristic regions. So the Southwestern Cape, Oteniqua, and Drakensberg fall under the Afromontane region. This region is characterized by forest patches, wooded kloofs, and also water catchments. And it's the largest and most diverse, has the largest and most diverse bioflora in the 4 biofloristic regions. So this region has a mountain and high altitude ecosystem, and these ecosystems provide a variety of habitats and also variety of microclimates for the bryophytes to thrive. And also the area is dominated by pleurocarpus mosses that have long stems and also elevated sporophytes. And also, guys, the Kamisberg, Zetterberg, and Southwestern Cape also are on the Karoo-Namib region. So this region is the 2nd largest in those 4 that we see on your right. So this region is renowned for its bryophytes, which have evolved to thrive in challenging arid regions. So they are in the succulent Karoo, in the Northern Cape. An example of such species is Apotheaceae genera, which are often referred to as mosses of harsh conditions. So they are characterized by compact and short stature, and they remain buried in the substrates. When we look at the biodiversity hotspots in Africa, we can see that three centers, all our centers correspond with the three biodiversity hotspots, which are succulent Karoo, Cape Floristic region, and also Maputa land, Pondo land, Albany region. So it was mentioned also yesterday here by Sally Archibald that by 2050, it is predicted that our terrestrial biomes will shrink by 40%, which means all those habitats where we have the endemic species, they are going to shrink or shift to the east. So we are going to lose a lot of biodiversity, and bryophytes that have limited dispersal capabilities won't be able to establish in new habitats. As a result, we are going to lose species diversity, species endemism, and also the biodiversity hotspots as well. So we need to collaborate. So people who are dealing with monitoring are welcome to collaborate with us so that we can monitor what's going on in our ecosystems. And also representation is important. We need to represent on these small plants. It is important to sample also the complete range of biodiversity so that we can be informed and also achieve the conservation targets for biodiversity. These are the references that I used. And thank you very much also to the University TUT for funding this. Yes, thank you.
Thank you, Nunkululu. I promise I won't make any jokes. Are there any questions, concerns, complaints? There we go.
Thank you. First of all, I want to say I'm very proud of my colleague. She has spent so much time studying bryophytes, and when she started this, I said, what is a bryophyte? Because I'm a social ecologist. But I just want to ask, what is the difference and how the two bryophytes adapted, the short-stemmed and the long-stemmed, how are they adapted?
Thank you, Dr. O. So the ones that are in the arid regions have a short stature because they need to conserve water since they are in harsh conditions. They have a short stature and short stems, and also the sporophyte itself is short, but the ones that are in the Afromontane have elevated sporophyte so that the sporophyte can be exposed to the wind for dispersal, and also the long stems so that they can be exposed to the light. Remember, the area is forested, and so they need to reach out to the light for photosynthesis to happen. Thank you, Dr. O.
Thank you. All right, next we're going to stick on the theme of bryophytes. We're going to have a little snapshot on the 2023 Jennifer Ward Oppenheimer Research Grant. And we've got Lova Marlene talking about that.
Hello, so I have 14 slides and 10 minutes to talk about mosses, mountains, and monitoring today. But before that, I'm going to show you this very beautiful photos I took 2 weeks ago. So this is the capital city of Madagascar, Antananarivo, and That photo I took from my balcony. And there's no filter. Those are smokes. And needless to say that I did work from home that day. It's impossible to breathe. The air quality is very worrying. And this period of the year, September, October, November, the main cause of air pollutions are brick making, forest burning, and really bad vehicle emissions in the capital. And that period of the year as well, we have a very long delay in the rainy season. So we have all of those particle matters, all of the smokes that are actually staying in the air. They're not going anywhere because we don't have rain to shave them down. And so what am I telling you all about that? Is that in Madagascar, if you've seen a map of the vegetations of Madagascar, we have the rainforest corridor in the east. And so you would think, you go to the rainforest, oh, the air is going to be good. It turns out it's not that good. And so the rainforest of Madagascar is actually are beautiful, hosting lots of species, of endemic species. But then this one time in November 2022, I decided to go on a hike, bought an air quality sensor with me. It's a mobile air quality sensor that would give you real-time information about the air quality in an area that you go to. And so if you know about the WHO air quality guidelines, if you have a green color, that means the air is good. If you have yellow, that means it's moderate, it's okay. And then if you have orange, it's bad for sensitive people. Now we've been walking deep in the forest, about 10 kilometers now. I got really frustrated because I get orange, yellow, and sometimes red. So now you think rainforest, clean air, turns out no. And so for Madagascar, those rainforests are hosting a huge number of endemic species. And so just to give you an idea, I was hoping that Steve was going to talk about the biodiversity of Madagascar yesterday, but he actually talked about the extinct ones. So those are the alives. 90% of the vertebrate species in Madagascar are endemic. 80% of the 9,000 vascular plants are also endemic. And so those species that are unique to Madagascar, many of them also occur in the rainforest. And so this rich biodiversity is actually at risk. So one of them is fire. We have uncontrolled fire. Around September, August, we have also the annual practice of slash and burn for agriculture, where we cut the forest and then burn it for agricultural purposes. Biodiversity also at risk by overexploitations and then fire regime. And now I also find out that, you know, we have issue with pollutions in the rainforest. And so that is actually one of the biggest motivation for my research project now. And so we have all of these species very well known to Madagascar. We know that they're critically endangered. Extensive work has been done with them. But then there is this group, as Uncle Lulu was telling to us a little bit earlier, that not just for South Africa, but for Madagascar as well, it's one of the most neglected components of the biodiversity. And so we do now have about 1,200 species in Madagascar, but that is based on very old literature compilations and a couple of exploration that's been done in the late 90s and some of our work. And so I'm kind of confident to say that about 25% to 30% of the 59 square kilometers surface of Madagascar has been explored in terms of biodiversity of mosses. And so more exploration will definitely bring up more species in the island. Oops, 5. And so they have no conservation studies as well, as stages as well. So because of all the habitat loss and threat, we we actually urgently need to study them before we actually lose them. So we don't want to have mosses. In the previous talk about the extant species from Madagascar, we wanted to keep them in their life, but not the extinct. And so what is all the fuss about mosses? So I'm not going to go a lot on this because it was clearly explained in the previous talk, but I just want to say that because they don't have roots, and they also don't have the well-developed vascular systems like the vascular plants, Bryophyte actually collected the nutrients directly from the whole surface of their body. And so they collect droplets of water from the environment, so they're highly dependent of that. And so that makes them a really good candidate to study impact of environmental changes on biodiversity. But also they are very important ecologically because they host 95% of their body mass in water, so they help you prevent, especially in the tropic, erosions, and also they help with nutrient cycling. So we really need to study them because of that. And so my study systems is mountains, so it has nothing to do with the fact that I'm a very keen hiker and I love mountains, wink, wink. But the fact that the mountains of Madagascar has never been really studied. So if you look at the literatures, we lack collections from the herbarium, from the mountains. Now, mountains are known to be hotspot of biodiversity. They host a lot, especially Madagascar, rich endemic species, also rich high species richness. We don't know so much about mosses. So now I'm very keen to understand the impact of environmental changes on biodiversity. So on a moss perspective, mountains is the best model system to study mosses, just because from low altitude to elevation, we have change in temperature. We have temperature that's decreasing, and then relative humidity also changes. And moss, as I said before, really depend on the amount of humidity and droplet of water in the environment. And so it changes throughout the elevations. And then on a moss perspective again, the type of vegetation from low altitude to the summit of a mountain change. We go from rainforest, tall trees, and then the trees, the length, the height of the trees decrease as you go up, all the way to having a savanna or mountain grassland. And so we have all of those changes, and this is a really good candidate to understand species distribution and how this kind of environmental changes can shape the distributions of the small community of mosses. And so where are all my labs? So I've got 4 labs in Madagascar, 2 in the northeast of Madagascar, and 2 in the southeast. And thanks to the GWO grant, I'm going to go for a hike in the Usumara in Tanzania and in Rwanda as well to look for mosses and trying to understand the diversity and distribution there. And so my last I was going to be doing the moss mountains monitoring as a people, place, planet, copying the way they do, yeah. And so we do monitoring of biodiversity in the mountains because, as I said, we like a lot of data, so we wanted to look at how many species are there, how many species are endemic, and then we wanted to understand the distribution and the diversity and the pattern of distribution. So I was looking at the poster yesterday, and they were mentioning that to monitor biodiversity, we need to study the change in species at a location rather than the change of the species location. So I completely agree with that. So that's what we're going to do. So we try to understand what is the distribution and the diversity of species from low elevation to the altitude, and then we try to compare different mountain systems and see what's the connection there. And so we were talking about pollution earlier. And so we also wanted to use, because of that capacity of mosses to accumulate anything that's in the contained in the droplet of water that goes into their cells, we wanted to measure the potential toxic elements that can be has been bioaccumulated in mosses. So throughout elevation, we're going to be choosing a couple of mosses to study that. The idea for that is that we wanted to also monitor air quality in the rural and urban area in Madagascar. Issue is we have a problem of load shedding in Madagascar. A couple of days ago, a whole morning, no electricity. So if you wanted to monitor air quality, you need data loggers that need electricity. We don't have that, and so we wanted to use mosses as biomonitor for air quality. And so that is basically what I'm going to be doing using the GW research grant, and stay tuned for more result. Maybe next year I'll get 30 minutes, not 10. And so thanks to the Jennifer Ward grant as well, we were complaining about 50% of the biologists in the sub-Saharan region are in the room, so we need more. And so we are now training 2 Malagasy students in biology. They are very excited about looking at mosses on a microscope, but also we are going to work with local population for air quality monitoring. So now we are giving them air sensors, but soon we're going to be distributing moss as well, maybe moss with a little bit of orchids as a gift for them to participate in the study. And on that, I would like to thank you for having me. Thanks my field team that's always supporting me when I go up the mountains, Steve, my supervisor, and Alex Antonelli from Q, and also the grant for generously funding this research. And I'm going to leave you before tea with this beautiful photo of a liverwort. Thank you.
Thank you so much, Lova. If anybody's got questions for her, please do find her in the tea session. Let's give another round of applause for all of our speakers this morning. Thank you, guys. All right, we'll jump straight into tea. It is going to be cut short, but please don't blame any of the speakers. If you want a Bryophyte with anyone, come to me. We'll be back at 11:10. Thanks, everyone.
Yeah. Really wish this wasn't happening.
Welcome back, everyone. My name is Pumla Dlamini, and I'll be chairing the second session for today, the last session of the conference. And first up, I'd like to welcome Lynn Wadley, who'll be speaking to us about the rock art of the Waterberg, Journeys of Transformation.
Good morning. The Waterberg is in the the western part of Limpopo province, and you see it there. In the 1990s, Ben Smith and Rari of Wits University plotted about 40 rock art sites in the Waterberg. And since that time, Gilran Lau and I have plotted a further 100 or more, and we now have a great many sites that you can see plotted there along 3 river corridors. Waterberg archaeology is unusual, and it's been excavations that have demonstrated that. Maria van der Rest started that out together with Jan Okemer and Jan Boyens, and they did some work early on there that showed that human occupation was mostly absent between about 2,000 years ago and between about 30,000 years or more ago. We don't yet know the reason for that, and it would be very nice to have some environmental collaboration in areas where the archaeology can't give us those results. But what that means is that northern Sotho and other early Iron Age farmers, together with the Bushmen, moved into the high Waterberg regularly from about 1,600 years ago. And that's really important for the archaeology because it means that unlike many other areas of South Africa, Bushmen were not the first people to occur. So the Iron Age farmers and the Bushmen interacted, and they probably understood each other's cultures and technology very well, and they would have exchanged ideas. And this is really important when we get back to the rock art. Both groups painted. So to look at Bushman rock art first, this is fine line brush painting using things like powdered ochre mixed with binders that may have been fat, blood, plant resins, and so on. Whereas the Iron Age farmer art was finger painted using only white river clay. The farmer art was instructive. It was very crude, if I can use that term, compared with the Bushman art, but it wasn't intended to be art for art's sake. The boys who were at their initiation ceremonies after their circumcision were taught about totems, their surnames that were often animal names, and also the cultural practices of the various groups. And so that was the art, what the art was intended for. Now, these rock shelters in which the paintings occur were used by both the farmers and the Bushmen as a kind of timeshare, we could say. And if you look at this particular image, you'll see that Bushman paintings are both underlain and overlain by the farmer art, the finger paintings. And this shows that people were using the rock shelters in a sort of contemporary way, but obviously not simultaneously. Now, in our Western viewpoint, painting over somebody else's art would be considered graffiti and rather destructive. But that wasn't the case in the past. The idea of painting one set of paintings over another would be to confirm, to suggest that the ideas were very similar and it was a supportive gesture. So in short, these people who moved up onto the high Waterberg more or less contemporaneously probably shared a symbolic literacy. But what is the overriding theme of the art we've looked at so far? The farmer art is about transformation from boy to man, and the art reflects a man's worldview. And that made me think that perhaps Bushman rock art wasn't too dissimilar in this particular region because of the interaction between the groups. In most of southern Africa and in many other parts where there's rock art, the dominant theme of transformation is about the trans-community healing dance. And the work of David Lewis Williams has shown that particularly effectively. But in the Waterberg, we're not seeing this. We're seeing very little evidence for the community dance. We see lots of evidence for altered states of consciousness, which are also connected to the community dance, but it's a different kind of art. So Bushman motifs in the Waterberg seem to emphasize hunting and weapons and animals, and I wondered whether such vignettes might represent the transformation from boy to man, in this case hunter, in a rather similar way to the farmer art that I've been talking about. So there's a great deal of emphasis on arrows and the detail in the types of arrows. I can't show you there, but you can see some are crescent-shaped tips, others are pointed, and so on. So I then immersed myself in the ethnography about Bushman Chakma, which is the group initiation of boys. And Lorna Marshall did some wonderful work in the 1950s in the Nainai area. And although women are really not supposed to know about Chakma, she was very persuasive, and she had one of her sons there with her who was helping her to do the interviews. And so they got a lot of information. And here you see some images of the practice sessions, the dances and the song making at Nainai before the boys went off into seclusion. This is a very different kind of music and dancing from the community healing dance that we see in other parts of the Nainai ceremonies. So it's a strong stamping movement, and the songs imitate animal sounds, and the dancers also imitate animal movements. And once the boys have learnt this preliminary music and the dancing, they then move away into seclusion with their mentors for about a month. It's extremely important that they have no contact with women during this time or children, so they're entirely alone with their mentors. What is Chakma intended to achieve? And what Lorna Marshall said was the boys were to learn sense. And of course, what she meant by that was maturity. But they also had to learn cultural practices, the social etiquettes, and various food avoidances, which became important for a long time after Chakma. They also needed to learn endurance, so they had to overcome hardships, deprivations, fear, pain, all the things that would be needed for men who needed to go out hunting, particularly endurance hunting, for long periods, perhaps with no water, no food, no support system. So I'm going to move straight into a rock art panel that I think helps to demonstrate that this kind of initiation system probably did take place in the past as well. And this is on Setakani Mountain in the northern parts of the Waterberg. And the rock art specialists always insist that it's important to look at an entire panel rather than to look at simple motifs in isolation. So I've picked out 5 motifs on this panel that I'm going to be talking about. The first one is the circle with a number of men dancing and clearly in an altered state of consciousness. Marcus Peters had interpreted this as a trance dance. But we notice that here the people are of different ages, so perhaps they're boys as well as men. Now, the Chakma boys had to dance all night with very little food, very little water, and you can imagine that they would go into altered states of consciousness during the time that they were doing that dancing. The second panel is of 3 Waterberg posture figures at the top and 4 high-stepping men at the bottom. Now, I'm going to come back to this picture, but I just need to explain to you what Waterberg posture figures are. This was a term coined by Gilrain Lauer, who did her master's thesis on this topic. These posture figures are usually in processions, often about 6, 7 men. It's a stylized profile. They always have extremely prominent sexual features, but hardly any head at all. It's a little peg head, and their arms are attenuated. They're very short and useless. They never carry bows and arrows, sometimes sticks. And I wondered if these were metaphors for initiates. So these are boys who've reached puberty, but they're not yet mature. And in the sense of Marshall, who said that the boys need to gain sense, those little peg heads might be indicating that there's not much sense there, yet the brains are still very small, and the arms are useless. Now, the Chakma boys would often hear terrifying sounds in the night, and they were told that that was a monster waiting to lick their blood. And I wondered whether this therianthrope that is about to bite that terrified human was the sort of image that these boys would have imagined. So to come back to the Waterberg posture figures and the men that are high-stepping below, those men are carrying bull roarers. You can't really call it a musical instrument, but it's an instrument that you whirl above your head and it makes a screeching, bee-like sound. These are secret artifacts that are hidden away between various Chakmas. They may never be seen by women or children, and not by initiates until they have been initiated. This is the big mystery of Chakma. On the last night of Chakma, the boys get tattoos. So they get cut marks made on their bodies, and something is rubbed into them. Their eyes are closed over, so they can't see what's happening, and they're told that it's the monster licking their blood. But in actual fact, it's the bull roarer, the flat piece of wood, that's being rubbed over their backs. These are modern bull roarers that were collected by Percival Kirby. So you can see there's some variation in the style there, but they all have essentially the same sort of design. I told you earlier that women and children were not allowed anywhere near the Chakma scene, and down at the bottom of that panel, we have this little scene of 2 women stopping dead in their tracks, a child at the back grasping the mother, and a couple of children in the front. So they have almost accidentally stumbled onto this dangerous Chakma site, and they're being halted, and they will be sent home again. Now, the Chakma boys were forbidden to eat certain categories of meat for a year afterwards. Aardvark is one of those. And here on this panel, we see an aardvark therianthrope very close to those dancing boys. So in conclusion, we need to look at entire panels when we're making interpretations. And the Setakani panel seems to house several strands of evidence for Chakma, an all-male dance scene, stylized depictions of initiates in the Waterberg posture, the use of bull roarers as the great mystery of Chakma, exclusion of women from the Chakma venue, and depiction of animals in the food taboos. Thank you.
Thank you, Lynn. Unfortunately, we don't have time for questions, but if you have any questions for Lynn, please catch her during the lunch break. I'd like to welcome our next speaker, Lokadia Dingwenya, who will be speaking to us on the reproductive phenology variations of Chakma baboons in southern African biomes.
Imagine a vast South African landscape, the earth dry and cracked, the tree with sparse leaves stretching towards the scorching sun. Then the season changes, rain clouds roll in, the landscape transforms and life responds. This is the dynamic environment where Chakma baboons call a home. Good morning, ladies and gentlemen. I am Lokadia Dingwenya. I'm doing my final year master's at Nelson Mandela University. And today, I will be talking about the reproductive phenology of Chakma baboons in southern African biomes. Now, reproductive phenology is defined as the timing and frequency of birth in an annual cycle. Over the years, Chakma baboons have been believed to give birth throughout the year with the same frequencies. But given variability in temperature, food availability, and rainfall, social hierarchies as well as predation that persist in the South African biomes where these Chakma baboons thrive in, one would theoretically expect them to synchronize either the time they spend at conception, paturation, lactation, or weaning with the time of maximum resource availability. Now, one would wonder why Chakma baboons. Chakma baboons are an ecologically successful, omnivorous, non-humid primate species, which unfortunately has not been able to be studied over a large geographical area, but has managed to colonize and survive almost all the biomes of South Africa, ranging from the hot and dry deserts via the savannas to the wet and cooler forest biomes, which then has driven us to our question and our aim to see if there is variation in the reproductive phenology of Chakma baboons in these biomes. We then used camera-tape data sets which was collected from 2017 to 2019 in 6 sites. As you can see from this map, we had 3 biomes, a site in the fynbos, a site in the Namakuru, and 3 sites in the savanna. So, after cleaning this data set, we remained with 230,000 420 images, of which 11,362 were Chakma baboons. So we then combined this data set and downloaded the images. We also analyzed these images manually to be able to assess the ages of juveniles in time-lapse image analyzer. As we all know that baboons are born black with pink skin color, we used these traits to estimate their age from 0 to 8 months. So we were using these morphological features on this table as a guideline, which was designed by Dejoie, to assign ranks on Chakma baboons, coat color and skin color, so that we would estimate their age. And then, since color is subjective, we then had 2 other experts analyze the same dataset and compare if the results were the same. After this, we then calculated the relative abundance index of juveniles, which is just the number of juveniles relative to adults in a month, and it was corrected according to the sampling effort. Now, we then subtracted the age from the date of capture to be able to see when these baboons were born. So our first question was to see if timing of reproduction was varying among years within sites. So in APN, which is Associate Private Nature Reserves, we compared these 3 years, 2017 in yellow, 2018 in pink purple, 2019 in navy blue. And it seems like baboons were remarkably consistent when it comes to their timing of birth within the sites. The same results were found for the rest of the sites that were tested, except for the Tswalu, where 2017 and 2018 were significantly different. Therefore, we had to take out Tswalu from our analysis because we could not compare these sites per each year due to data insufficiency. To see now if the birth timing in Chakma baboons within the sites was uniformly distributed, we used the Komogrov Smirnov, and it seems like in as much Chakma baboons give birth throughout the year, they are showing a minimum level of seasonality, as you can see with the peaks on the graphs. So we then compared these size, and out of the 10 pairs that we had, 3 were significantly different, which is APN and Dilhoop and Madikwe, and APN and mountain zebra. But since our sites were distributed along a very long latitudinal gradient, we really needed to understand if geographical location mattered. So we compared the distance between these sites with the differences in timing of reproductive phenology using a Mantel's test. And unfortunately, distance did not matter. Then we needed also to see if this variation was attributed by the environmental variables. So we tested the timing of birth against the timing of temperature, rainfall, and NDVI using cross-correlation coefficients. And this is what we found. In APN, Chakma baboons are giving birth 3 months earlier than the peak of rainfall. In Madikwe, 10 months earlier than the peak of rainfall. But in Dilhoop, they are synchronizing the exact time of birth by the peak of reproduction. So we then realized that this could be attributed by environmental predictability. As you can see in the savannas, where rainfall is variable and unpredictable, these baboons prefer to give birth earlier with the hope that by the time the juveniles stop breastfeeding, then there will be enough food for them to survive. But in the hoop, in the fynbos, where rainfall is more predictable, you'd see that the baboons are giving birth at exact time where resources are at maximum availability. Interesting enough, in the Karoo National Park, which is very arid, we realized that Chakma baboons were giving birth approximately a month earlier before the decrease in NDVI, which is a proxy for food availability, and 12 months after the decrease in rainfall. Now, this is surprising, and also it's scary, in the sense that we were expecting baboons to align their births with availability of resources, but there is a phenological mismatch. And this could also be early signs of climatic vulnerability on these baboons. However, in the mountain zebra, these environmental variables did not have an impact on our Chakma baboons. But then what does this mean? We see that timing of birth in Chakma baboons is not a one-size-fits-all, with baboons giving birth, with the timing of birth in baboons being shaped by environmental variables, especially rainfall. Now, these baboons are not reacting immediately to these conditions, but they are planning well in advance. So we can get a lesson of planning, adaptability, sometimes a well-calculated risk for them to be able to survive. But if as flexible as they are, baboons are responding like this to these climatic variables, then the question remains, how about the not so flexible animals that are threatened? With this, I thank you.
Thank you, Lokadia. We have some time for questions, so if anyone has any questions for Lokadia. Okay, no questions. Thank you, Lokadia. Up next, I'd like to welcome Justice Muvengwi, who will be speaking to us on the early results from CSO, a network of people, plots, and methods to understand global change impacts in Southern Africa.
Good morning, ladies and gentlemen. My name is Justice Muvengwi, and I'll be speaking to you about the early results from CSO, a network of people, plots, methods to understand global change impacts in Southern African woodlands. So probably the first thing is to understand what that acronym CSO means. CSO means Socio-Ecological Observatory for Studying African Woodlands. So this is a long-term network of vegetation plot infrastructure covering the largest savanna in the world. So it's a collaborative partnership, it's a collaborative partnership of African research and management institutions and other stakeholders. So what we have within the network, we have quite a number of institutions. Like here in South Africa, we have Sunparks, we have Rhodes University, we have Wits University. So it's communally managed, but it has some governance structure. So it has got two co-chairs. One is based at Wits, the other chair is based at University of Edinburgh. And it has got a steering committee under that top, below the co-chairs, we have the steering committee, and the role of the steering committee is to steer the direction of research within the network. We also work on protocols, trying to develop standard protocols for data collection within these savanna woodlands. So anyone can deposit data within the CISO, and anyone can also make a data request from CISO. It's also the responsibility of the steering committee to assess all the data requests so that there are no overlaps. So if you apply, or if you lodge a data request to CISO, then the steering committee will look at your application or your request, and then they make a decision based on what other research is going on within the network, whether there are no conflicts or clashes on what you are trying to do with the data. So what we have achieved so far as a network, we have measured more than 600,000 trees across over 10,000 plots. So it's a huge achievement that has been done by this network. As you can see on that map, in kind of peach, those are permanent sample plots, and in green to a bit of some yellow, those are once-off plots. So now I want to emphasize maybe the importance of those permanent sample plots. So permanent sample plots, they enable us to define sustainable harvesting. We are dealing with natural woodlands, and we need to harvest sustainably. And they also help us understand the demography of these woodlands in terms of growth, recruitment, and mortality. And also, we are able to understand how these woodlands respond to local and global drivers, such as climate change, harvesting carbon dioxide increases, or fire and herbivory. So it's quite important to have these permanent sample plots. And the drive is to make sure that we keep on measuring with our resources allowing. We need to go maybe after every 2 or 3 years to remeasure those sample plots. So CISO was formed around 2017. And as you can see, that vertical dotted line on the bottom graph to my left when I'm looking at the screen, there is some cumulative increase in terms of the number of permanent sample plots within the CISO network. So what is CISO's impact? I think we have made a lot of impact. CISO conducts high-level science. We have studies that focus on biodiversity, some on ecosystem services within these woodlands, and some on ecosystem functioning. We provide the only validation data in dry tropics for biomass change. Committee on, we provide, we validate satellite packages that are used in remote sensing. So when they want to validate or calibrate their data, they use some of our plot data to validate those satellite missions that they send across maybe Africa in trying to understand the biomass that we have within these woodlands. We also assist our partners, organizations. We've got partner organizations within the network in terms of meeting their reporting requirements for organizations RED, UNFCCC, CBD, or UNCCD. We also support capacity building and networking of African researchers. To date, I know quite a number of researchers across Africa, like in countries like Kenya, Tanzania, Malawi. So I've interacted with quite a number of researchers from these countries. And I think previous speakers from yesterday, they were also emphasizing on these partnerships and the importance of these partnerships in terms of capacity building. So these are some of the research outputs that are coming out of the CISO network. It's not all of them, but I've just given you a bit of them. And they range from those focusing on diversity, some on biogeography of these woodlands, and some on carbon sequestration. So what I'll do is I'll summarize maybe 3 studies that have emanated from the network. So the first study that I'm going to summarize is by Gotore et al. On wood biomass increases across 3 contrasting land uses in Urungwe Mid-Zambezi Valley. So he sampled across 3 land use types, that is the protected area, a buffer zone, and the communal area. And it's interesting to note that their basic method was phased array L-band synthetic aperture radar observations. And what they discovered is that woodland cover for park and buffer was higher than communal area for 2007 and 2017. So during these 2 time periods, there was high cover for the buffer and the protected area. When it comes to 2007 again, the mean above ground carbon stock was not different across all the 3 land use types. However, in 2017, above ground carbon stock was higher in the park than both the buffer and the communal area. So what was the take-home point from this study? I think they discovered that woodland cover and mean above ground carbon gains outweighed losses over the 10-year period. This doesn't necessarily mean that there are no negatives that are occurring within these woodlands, but they discovered that there were some gains in terms of woodland cover. So another study, which was carried out at a large spatial scale, focusing on above ground carbon stocks, was by Mark Nicol and others. So in this study, they looked at several countries using a similar method, and they witnessed high rates of degradation and deforestation, but also they observed extensive regrowth across the region. So if you look at these 2 graphs, one on the left on percentage of wooded area and the other one on carbon stock change, you would see that forest degradation was more important than deforestation when it comes to percentage of wooded area, as well as when you're looking at the carbon stocks, carbon losses via degradation were more important than deforestation, which is kind of interesting that there is a lot of woodland degradation that is occurring across the region. So the take-home point from these 2 studies focusing on above ground carbon stocks is that sustainable resource utilization is possible without loss of ecosystem services, such as carbon sequestration or climate mitigation. So now I will take you through another study, which is currently in press by Gotore et al. Again, on tree growth rates and their determinants inform sustainable harvesting of indigenous woodlands in Zimbabwe. So in this study, they measured 2,731 individual stems belonging to 4 different species over a 27-year period. And they found out that the median species stem growth rate was 1.31 millimeters per annum, and with a median growth period of 328 to reach harvestable size of 35 centimeters. So it takes time to reach the required sizes or volumes of these woodlands. All the need for sustainable utilization and also proper management of these woodlands. So they also observed that precipitation had a positive influence on stem growth rate. But they discovered that as the basal area in square meters per hectare increases, then stem growth rate decreased quite a lot. As you can see, growth rates decreased from 2.8 to 0.8 millimeters per year, as the plot level basal area increased from 10 to 20 square meters per hectare. This increased the time to reach harvestable maturity by 70%. So what are the implications? They suggest a very simple answer to this. Productivity can be managed by thinning to reduce competition. So once you reduce competition, there are chances that you reach the maturity stage much faster, you cut on the time. So long harvesting cycles are informed by competition, carbon dioxide, and precipitation. So from here, I'll give you a brief description of what I'm doing within the CISO network. So what I'm trying to understand within the CISO network is that I want to understand how various aspects of diversity change across the vertical vegetation structure. So moving from the understory vegetation to the overstory, I'm trying to understand how maybe richness changes, turnover, nestedness, so beta and alpha diversity, how it changes. Because I think and I feel that there's a lot of diversity that is hidden within the understory level within the woodlands. So I've developed some questions. So the first one is how does alpha phylogenetic diversity vary across size classes? So my assumption or my hypothesis is that species richness will go down with an increase in what? Diameter size classes. And also phylogenetic diversity will go down with an increase in diameter size classes. So I assume in the understory I'll get a lot of diversity. That is when I'm considering what we call the small stems within these ecosystems. So another question I have is that what is the taxonomic and phylogenetic turnover of savanna trees across stem size classes? And I think species nestedness is going to increase with the increase in stem diameter. So what are CISO's future goals? So goal number one, more is more. We want more people, we want more plots and projects within the network. So we are inviting people to be part of the network, actually. So if you have your vegetation plots that you have measured before, feel free to deposit your data into the network because you are able also to withdraw your data, and we don't take your rights over your data even if it's within the CISO network, right? So make sure that if you have data, approach us, and then we can deposit your data safely into our CISO database. Capacity building, data workshops. We want more data workshops, summer schools, fieldwork workshops. I like the fieldwork workshops more because they are practical and theoretical at the same time. So you go, you do a prac, you come with some data, and then you test the data. So they are quite good, especially for students. And networking, we want to extend partnership to co-develop impactful research. So we want to increase our network. So this was my last slide, and I would like to say thank you to the organizers of this conference for inviting us as CISO. I am representing CISO, not myself. Thank you.
Thank you, Justice. We have time for one question if anyone would like to ask Justice a question. Okay. Up next, I'd like to welcome Helen Van Zyl and Andre Tranquillini, who will be speaking to us on 100 years of biodynamic agriculture, a model for sustainable farming, climate mitigation, and future opportunities in Africa.
Thank you. Thank you very much. Good morning to everyone. Firstly, I would like to thank our hosts, not for only for the incredible generosity, but the incredible vision to have held such a conference for 13 years. I had the opportunity to participate and the privilege on a few of them. And what we see is seeds, threads of conversation, research being developed. So there's a real impact here. So that's absolutely amazing. Also extending my thanks to Duncan and the whole team who have been doing, as usual, a fantastic job. There's been such a diverse conference. We heard from scientists, conservationists, obviously, but also from business people, from philanthropists, from barristers. This morning, we even heard from meerkats. You're stuck today, now for the next 30 minutes, we're stuck with 2 farmers to increase the diversity of the conference. So I'll be sharing the presentation with my colleague Helen Van Zyl from the Biodynamic Association in South Africa. And I will be talking more, perhaps from a European point of view, and Helen will then bring what we're talking within the African context. So I won't do the doom and gloom thing. We had quite a bit of that already, but it's important to say that a lot of the symptoms of the crisis that we're facing, being climate change, being food security, being biodiversity loss, they're intrinsically connected to food production. Yeah, so that's a call there for the scientific community. I know this call has been made by many different presenters, but we really need to look how we are producing food as a real means to mitigate some of the symptoms that we are facing nowadays. We cannot separate the question of food security and the question of biodiversity loss. They are the same question. As we know, industrial agriculture is the second biggest contributor to climate change. And we're seeing large-scale ecosystem degradation totally linked to food and farming. 100 years ago, that's when biodynamic agriculture started. It started in where is now Poland, and it's really quite interesting because it started from questions from farmers, who at that time, post-First World War, were the first that were working with chemical agriculture. As we know, the Green Revolution was a byproduct of the weapon industry, so that's where artificial fertilizers came from. So those farmers were already meeting issues with vigor and quality of their seed. So then they approached Rudolf Steiner, who delivered 7 lectures. This is a statement of one of the lectures. I won't cover all of that, but I think it's really important to highlight the fact that already 100 years ago, at least within this agricultural system, we were identifying the fact that without biodiversity, which is our main tool for prevention of pests and diseases, without biodiversity, we cannot produce food in a sustainable way. So that's already 100 years ago, which is really quite exciting. So after this cycle of 8 lectures, a first experimental group was formed. So people who were attending those lectures came together and started to develop the practice. So that really is where the origin of it. In fact, this whole aspect of biodiversity, conservation, and food production has not only been fundamental in terms of our practice, but has been a standard of certification for, again, almost 100 years. So what we're seeing here, the Demeter brand, so every biodynamic project you will see is certified by the Demeter brand, so that's an international brand. It's the oldest and longest practice form of quality assurance in sustainable agriculture, and it is an international standard. So currently we have 65 countries with biodynamic certified farms in all continents, and every country has to work with these international standards. Of course, there's national changes depending on legislation and so on. One of the prerequisites is that we have to be firstly organic, so every biodynamic farm is firstly organic certified and then become Biodynamics. And our standards go above and beyond organic, really, to meet some of the targets in terms of being environmentally friendly, ethical producing, sustainable production, and so on. So now I will present just a few of the key concepts, and they are so simple that they are complex. And you'll be able to see that. The key here is to think about circular systems, is to think about farming ecosystems, what we call a farm organism. So essentially, soil microorganisms will digest organic matter that will support plant growth, that will feed our livestock, that, and on the other hand, through their manure, will feed once again the microorganisms that will promote more organic matter production, which in turn will feed vegetable production, fruit production, cereal production, and support wildlife as we farm. So essentially, these dynamic soil ecosystems are dealing with climate variability. So it protects us from droughts, protects us from floods, cleans airs, clean water, delivers biodiversity, build communities. So we're really starting to build community from the soil up. And of course, we have the people, which really is part of this farm ecosystem. At the moment in the UK, we have a real challenging situation. Either, there's a strong voice for agricultural sustainable practices, really looking at localism and how people can be more connected to the food they eat, which is absolutely essential. But there's also another strong movement that is very powerful, that wants to separate people from the food that is being produced. So we're talking about lab-grown meat and food grown in underground bunkers with this, that, and the other. So we are in that threshold, literally. What biodynamic agriculture can also offer is a framework for decision-making. There isn't a recipe. Even though we're working with standards that we have to abide by, there isn't a recipe. So there's a real invitation for the people to be part of that farm ecosystem and made decisions based on relationships. They're finding a farmer. Of course, we use the data. We use all sorts of resources available to us to make decisions. But I would doubt that any farmer would sit down and say, okay, it's decision-making time now, and I'm going to decide what I'm going to do. We're constantly walking, we are being part of the landscape, and that's what is informing as well the decision-making framework. Another aspect of biodynamic agriculture, of course, farmers work with rhythms, with seasonal rhythms. In biodynamic agriculture, we try to optimize those rhythms and use them in our favor for plant growth and animal health, for the whole health of the whole system. So one of the things, for instance, that we do, we work with lunar rhythms. So we're looking at lunar rhythms and deciding when we're going to plant, sow, transplant, and so on. One of my really good teachers in the past said, with biodynamics, you don't say no, you just say oh. So this is a bit of the just say oh kind of mood. The next one is even more a just say oh kind of mood. And this is something that more and more as biodynamic practitioners, we are so thankful to you guys, scientists, and you're going to understand that in a minute. In order to maximize farm health, we work with plant remedies and preparations that we use ingredients from the farm to make. There are two sort of field preparations that we work with. One is the one you see on the picture on the top, on the middle, and that's the horn manure preparation. So essentially that's fermented cow manure, the cow manure has been put into a horn and is being buried for 6 months. Don't say no, just say oh. And that is then lifted, is then diluted, and then applied in a high dilution into the field. And that's where we are so thankful to the scientific community, because you can imagine, for 100 years, we've been standing in front of audiences like this, or even in farming settings, said, now we're going to get a horn, and then we're going to get the poo, and then we're going to put it inside. And I tell you, there was a situation in Spain. The face of the people looking at me would tell you, we're going to do that. But there's the research. It's so exciting, because after 100 years, things that we could share in terms of our experiences, now science is proving. So this has been published last year by Marina Zanardo, and she's done a meta-barcoding analysis of bacterial and fungal communities in the making of the horn manure preparation. So as you can see on the graph there, she measured the activity of both the fungal and the bacteria from when the feces all the way to when the preparation has been finalized. So what actually she found using gene markers is fascinating. She found a correlation, a rational explanation why the manure inside the horn. So there's a particular group of fungi, particular order of fungi, and they are known to be pioneers. So their activity is really important to release nutrient for other communities of fungi and bacteria that are following them. And that particular order of fungi that is present in the feces, because it's present in the cow lining, actually is what starts breaking the keratin that's inside the horn. So, and that's the pioneer species of the horn manure preparation. So thank you so much to the scientific community, because now we have that ability to say there is a practical reason as well that works. Another piece of research that I wanted to make you aware of It's from Kassel University, so again, it has been recently published. And we're looking at 5 years of research, 21 sites in France and 3 sites in Germany. And essentially, they were looking at the effect of the horn manure preparation in terms of the microbiome communities, microbial communities in the soil. So that's something that, again, gene markers have been used for that. What they found, they were able to prove that this horn manure preparation has various effects. Again, such developing the microbial biomass and also air in the soil. Soil respiration is extremely important, as I'm sure you all know. They also found significant numbers of plant growth promoting umbilical sequences in the biodynamic systems in comparison to the organic system. Another finding is that, because when I was telling about this spraying of this horn manure preparation, I'm talking about homeopathic quantities. I'm talking about very small quantities, which again was very hard to explain. These, with biomarkers that's showing all of that microbiological activity. And actually, they were able to prove that that impact of the preparation can be measured for 12 weeks after application. So this is something quite exciting. And now, for my last bit, and before I pass on to Helen, I wanted to highlight this dog trial, which for some of you may sound like a dream or a nightmare, because they've been conducting this research for 40+ years. Can you imagine if you had 40 years of research working on the same area, working with the same crop rotation, but of course the questions keep on changing. So that's something that is quite exciting. This came about in the early 70s because the organic farmers in Switzerland approached the federal government for research, because already then, as organic and biodynamic farmers, we're being told, oh, what you do cannot feed people, the world will go hungry, and all of those questions. So they have asked, actually, the federal government to look into this. So as you can see, they've been more than 120 scientific peer-reviewed publications, including a publication in the journal Science in 2002. I won't go so much into the detail of the methodology. Of course, it's agricultural trials, what we're looking at. So we're looking at a comparison between biodynamic, organic, and conventional agriculture. Later on, they added working with the same crop rotation. So we're looking at 96 plots of 100 square meters each plot. I will highlight just very briefly some of the figures that are really interesting to see. So on figure number 5, the amount of applied nutrients. So we have there no fertilization. Biodynamic 1 is low fertilization. Biodynamic 2 is the normal level of fertilization. We have also CONMIN, which stands for mineral fertilized conventional. Yeah, so there was no animal manure in there. So in figure number 5, you can see the number of applied nutrients. And you can see the green line, of course, on the no fertilization, nothing was applied. But you can see the biodynamic is lesser in terms of nutrients applied. So when we're talking about resources crisis, when you're talking about climate change, obviously I want less input and still be able to hold some level of output. So that's something very relevant. So from 1985 onwards, 45% less total nitrogen, 75% less mineral nitrogen, 35% less phosphorus, 27% less potassium were used in the organic systems. So how amazing is that? And very interestingly, the biodynamic soil actually measured to be the lowest in terms of phosphorus, because we're not adding any mineral phosphorus onto it, but the biodynamic produced were found to have the highest level of phosphorus. So go figure. Figure number 9, we're looking at quantity of active ingredients applied in terms of plant protection. Look at the conventional systems. Look at the quantity and the difference from fungicides, herbicides, seed dressing, and etc. Again, the biodynamic system, even lesser than organic. The quantity of active ingredients that were used in food production were much lesser. Again, such a relevant point of view. So higher microbial biomass, as we know, that's so important for soil health. and a higher density of spiders. I could go and show you of every type of invertebrates that were measured. The biodynamic systems showed a higher density. And this is my last slide. And then looking at soil carbon stock. So that's from 1972 to date. And we can see that the soil carbon stock, the biodynamic line is the green one at the very top, has been increasing each year. So that's part of the research I wanted to share with you, and I will leave you with healthy and fertile soil can be regarded as a threatened species. And I'll pass you to Helen now, who will talk about an African context.
Good morning, everyone. It is a privilege to be here to speak to scientists and ecologists. So I was thinking, how can I relate agriculture to ecology? And of course, we work very closely with nature, because that's the work of an organic and a biodynamic farmer. And yet we have made a lot of mistakes as farmers, and the conservationists are not happy with us. And yet I think there is time, and now that 100 years have passed, for us to have a stronger relationship. And we are so wonderful, this news that has come out, that the scientific community has accepted that what we are doing can be proven, and it has significant impact. Yet, I just wanted to go back briefly as to then how have we managed as biodynamic farmers to keep going when we were often scorned and told what we were doing is really crazy and it doesn't work and it won't have an impact. And yet, what was this in us that kept going? And there was a mention yesterday from somebody, we need to, in the scientific world, we need to also go on and try other ways of looking at nature and ourselves. And someone talked about curiosity, and this other, what was this other, there's so much to be known, maybe sometimes we need to leave aside the scientific research and look at things in a different way. And an inspiration to me has always been Goethe, because he said if we want to look at, he says we can't use the same method to look at the living world as we look at the inanimate world. And if you take a fish and look at it in the laboratory, it is not living. And yet there's significant results and very important results, and I would never deny that. But he says if you have to go further and expand your knowledge, you need to look at a fish in the water. A fish is not a fish without water. And also, water is probably not alive without these living beings. And this is a qualitative way of looking at nature that I have personally used in my farming, because I'm not a scientist, I'm a farmer. And as Andre said, there's oftentimes you're in the cold face of work, and things go wrong, no matter how well you've planned and you've programmed and you've trained and you're experienced and you've got a spraying program. Next day the hail comes, and last week it went on my young leaves of the apple trees, and there was little holes right through, and what do? And a friend said, spray valerian, and I just went immediately and did that, and didn't know why I was doing it. I didn't have a scientific reason to do it. But it is known that the essence of that flower is to bring warmth, and it was so cold and the plants were in shock. And so I didn't know, is this going to work or not? But the next day I went out to observe, and of course, the tear in the leaves is still there, the damage is still there, but what I noticed was there were just so many bees. I've never seen so many bees on the trees. And so through this constant interaction and being in the coalface, you're discovering more, because I was worried, because there's such a wonderful biodiversity and flowers at the moment. The bees were going to the flowers, or not to the flowers on my apple trees. And suddenly, this disaster brought this change. So this is the type of qualitative work we're doing as farmers. So we need a method that studies a living world. And of course, following on from that, I just wanted to briefly go back historically about this relationship to ecology and agriculture. So Steiner worked with this chap here, Pfeiffer, and said, when he was quite young at the time, he was a soil scientist, he said, you must prove these preparations that we're developing because in the future, people are going to mock it. You need to prove it scientifically. And so he's a scientist and he did a lot of research, as did Lily Kalisko. And what is not known is Rachel Carson's, who was the person to highlight the first person, I think, to highlight the damage of pesticides in the ecology and also in farming. And because before that, you had all you had Steiner wrote a book on biodynamic agriculture. You had, following on from that, you had people writing books on organic agriculture, Northbourne, Balfour, all of those. But no one was taking it up. So these books were written in the 20s and 30s as studies, but no one was taking up organic agriculture, even though people were aware that these pesticides and animals were becoming less fertile and there was less fertility in seeds. When Rachel Carson published her book, there was this shift in consciousness. In the early 60s, there was this shift in, gosh, we are really doing it. So you can have some truths written in the 20s, but no one takes, something happens in people, our consciousness changes. And what was interesting, what is not known, is that Rachel Carson's got some of her research when she was doing comparative trials on soils that were damaged with DDT and plants. She got her other research from a biodynamic farm in Long Island. And the people said to her, why don't you mention that you got your research from a biodynamic farm? And she says, oh my God, no, I could never. It wouldn't be accepted. The scientific community would mock me even more if I said that I was getting interesting results. I could say maybe it's from an organic farm, but definitely not a biodynamic farm. And it's this sort of thing that we have been working, biodynamic practitioners have been working for, it took 30 years for the research to be done and the preparations to be done, and when it was rolled out, even then, as Andre says, we have to say oh and not no, because otherwise we don't know. Yet farmers kept going because they saw the results. They couldn't fully explain them in a scientific way, but they saw it, and they also intuitively knew what to do next. And this is what I meant by the Goetheanistic way of thinking. Because you're so deeply engaged, you are part of nature. And the wonderful thing for me about the Goetheanistic method, scientific method, he says, well, in his time in the 1800s, Goethe said, if there are 200 Christian religions in New York, surely there must be a few more scientific ways of looking at things. So he developed the Goetheanistic scientific method. And in his case, the scientist is part of the experiment. The farmer, this is why I like it, because we're part of the farm. We have to get our responses from nature. We have to watch, we have to learn from nature, learn from the animals, learn from the fruit trees, etc. So how is all of this relevant to Africa? Which is why I was asked to be here. So I teach a 2-year diploma in biodynamics to the youth, which has been rolled out for the last 10, 12, 11 years. For farmers here, for them to learn, we have established a peer review system called Participatory Guarantee System, which is more to ensure that they're following good standards of practice, but also it has become a very rich way of farmers working together to learning from each other to build community of farming practice. And then eventually, for those who want certification, who can reach that, can get that. We have recently started a system for students who have been trained and for others to learn to become trainers, which is another skill. So it can be rolled out in various communities. And I've just come back from a couple of weeks ago in Botswana, where we had 20 trainees, and we worked with Sikkim Biodynamic Farm in Egypt, where they have been very successful in their biodynamic practice, working with 20 students to teach them how to train. And it was quite funny, because we said we had to work with these preparations, and as you can see, we're talking about a horn, and it was animal organs. And one of them came up to me and said, Helen, I never knew Europe, white people were copying us now, working with animal organs. So for them, it is normal to actually have these conversations and to work with herbs and this whole activity, because intuitively this practice in some sections has been going on. It's not the same, but it is not as strange as we have always had to, in a way, just pretend we weren't using these preparations. And there's a whole socio-cultural aspect to bring it to various countries. And we have practicing Demeter farms in South Africa. Not enough yet, but it is coming, and there is interest. I live in the Piketboerberg, and there are lots of farmers around me, and I assume they're not interested because they're chemical farmers. And every now and then they pop in, and you get jokes, and you're mocked because you're doing organic or biodynamic. But recently they have arrived and said, Helen, I want to know about this. And I, at this stage, don't even believe them. But now they said, no, sit down. We want to know, because our chemicals actually, they're not all working. And we don't know what to do next. Farmers have been set up for the past 2 generations to deliver more, take less money, produce more, pump more, and it's not working. And the time has come for organic and biodynamic and regenerative farmers to say, we've got a model. And it is the expansion that has come out of this course. There's now an indigenous biodynamic association in Africa, which has come forward to say, look, we want to find our own relatedness to this work. Because we've come at traditional knowledge. We want to see if these preparations have any relationship to the traditional farming practices in Africa. And of course, we welcome that. It's absolutely wonderful, because it must be an acknowledgement for this continent, for what's happened. And so they are thrilled that we are willing to work in this strange way, and we want to see together what have we got in common, and can we go forward together? And that is very exciting. So where are there, often people want to know where are the big farms, where are the big results, so we have some of those. Limbua is a very interesting project in Kenya. It's been going for a good 20 years, and they now export Demeter products, lychees and avocados and some mangoes. And they work with 2,000 and growing small-scale farmers, and 500 of those are Demeter certified, and they have workshops making the preparations, etc. And they've been coming to us for training the trainers, and it's very exciting. Similar, of course, which I'll show you in a moment, is Sikkim in Egypt, which is one of the best examples that we have in the whole biodynamic world. And then there's a wonderful learning community in Zimbabwe. They make fantastic preparations, and they're really committed. And then there's, of course, the Biodynamic Association in Southern Africa. And this is Sikkim, which started 40 years ago. In the desert, there was yesterday presentations about once the farmers have plowed up so much, the land becomes desert, and that's it, and it can't be rejuvenated. Well, Biodynamics has proven otherwise. This was a farm, an Egyptian studied actually Goethean science in Germany, and came back and got some land, and there was nothing on it. And the first thing he did was he dug a hole to get water, and then he planted trees. And now he's the largest biodynamic farm, 40 years later, in the world. Hundreds of hectares, there's about 2,000 farmers. He's exporting vegetables to Europe. And that soil, there was just sand, it was white. And I was there a year ago, and that soil is beautiful brown, and they actually were able to take a tractor over it and disc it and plant. So this work, and it's always been certified Demeter, and of course he also works, he has got schools for children, and he's now gone and built, they have a university, Heliopolis University, where people study biodynamic and organic agriculture, soil science, food science, and that's able to feed back into his farms. He's now starting a program to have close to something like 40,000 small-scale farmers trained and working in biodynamics. And this is all in very, as you can imagine, very arid, no-rain climates. So it's with that I'm very proud to thank you all for listening. Thank you very much.
Thank you, Andre and Helen. We have time for just one question, if anyone has a question for Helen and Andre. Oh.
Thank you very much, Andre and Helen. That was really, really interesting. As somebody who has witnessed the horrors of intensive animal agriculture as a veterinary student and veterinarian, I've always been interested in alternatives of animal production, but the big question always keeps coming back, as Andre alluded to. How do we scale this? How do we match the expectations of the human population for consuming meat with sustainability? Can we persuade people to eat less meat? Can we scale this up over the whole planet?
Would you like to take?
Look, I think in Africa we've got a possibility for a great, because of the numerous small-scale farmers, many of the organic practices, regenerative agriculture, and now biodynamics, we're working with small-scale farmers, and they're grouped together. Like this case in Kenya and Limbua, it's 2,000 small-scale farmers. And so if they work together, and if you work in biodynamics, of course, you have to have the animals are integrated. So it's about this thing of keeping it local and not this, we have this, it's unfortunate, the biggest challenge actually to organic and biodynamic farming is the food system. It's very difficult for a farmer to go into this food system because farmer is the price taker. So I think if we can emphasize the small-scale farming, feeding locally, and having an extra crop like they do at Limbua, so if everybody happens to have a mango and a avocado and a lychee tree in their back garden, and they have collectively managed to export this food. They have a central factory where they package, etc. So I think this concept that we can't feed the world is also part of this broken food system, which has driven the farmer to produce more and more and more and to become a monocrop farmer. In the whole organic, regenerative, biodynamic farmer, the ruminants, animals, are critical to the development of crops. And it's been shown. And I think that's how we must get out of this monoculture mindset. I hope that helps.
And if I may add, Zoe, thank you so much for your question, because animal welfare is crucial to what we do. So for instance, we could not scale beyond what a farm can sustain in terms of the number of animals, because we are producing all the feed that's necessary for the livestock from within the farm. And that relationship, in a way, is the highest level of animal welfare. And of course, then the stock density is not so high, so disease prevention is really, optimized. And as well, with the work with homeopathic medicines, with the cattle, so all of that is part of their welfare. One thing I have not mentioned from the dog trial is, of course, our yields are lower. We're 20% lower yields. But again, if you put in the balance with how much more input is going, if you saw those figures in terms of nutrients, the balance is there. It's just how to address the food system. So thank you. Thank you very much.
Thank you, Andre and Helen. Before I call on the next presenter, can I please ask that the Conservation International and FIFA presenters get mic'd up if they haven't already done so? Okay, up next we have Bernard Coetzee, who will be talking to us about reducing vector-borne disease risk by optimizing artificial light expansion across Africa.
All right. Hi, I'm in. Good morning. It's a pleasure to talk about some of our work on artificial light and mosquito interactions. And so if you've been to my talks before, you know I'm very fond of this image and this slide, and I couldn't resist putting it up again today, because it really paints the context of a lot of the work. And so this is called Earthrise. It's a very famous photograph that was taken during Apollo 8 mission, during a slingshot maneuver across the moon. And for the first time, any person in humanity's history came around and saw our planet rise, as it were, from another celestial being. And it's such a poignant photograph because it's this blue marble, as Carl Sagan put it, suspended in a sunbeam. But I want to draw your attention to the dark spaces. That's what's really important. And so we forget that the universe is, in fact, an exceedingly dark place. And that's really critical for our story today, because we know that the face of the planet is really changing and really rapidly changing with the introduction with artificial light at night, mainly from electrical infrastructure and electrical sources. Now, this is just a map from South Africa, but it's true for much of the Northern Hemisphere. Much of the world is now under significant levels of artificial light at night. Me and many others think it's a global change driver that's really altering biological systems. We can demonstrate impacts across the biological hierarchy, from microorganisms up until the higher vertebrates. And it's also increasing. It's also increasing in type. And so people are predominantly using blue LED lights, which is really changing the structure of biodiversity. And biodiversity on the planet has been subjected to these day-night cycles since the dawn of time, really since the evolution of species on the planet, and they fundamentally interact with light. And so we pulled this together in a manuscript saying there's all sorts of things we could do in an African context to advance artificial light research. But our goal really was to plug mosquitoes into that universe. So I'm an ecologist by training and by trade. I'm not a vector biologist. But mosquitoes, and I'll explain why, are such a fascinating model system to try and understand this. And given the big disease burden in Africa, we thought it was a critical topic. And so the whole, this is a broad level overview. You come to me with the details, but really the whole project was based on these 3 tiers. It's to measure how artificial light impacts mosquitoes in the lab. We want to measure how artificial lighting is changing in rural Africa, because that's really what's happening on the ground. That is the context on the ground. And basically, we're doing steps 1 and 2 to collect calibration data, to build models on disease risks from vectors. And our argument was just that one of the things that's missing is the artificial light aspect. So this is, again, like a simplification of the lab work. There's a couple of MECs and honor students related to this work. But basically, the lab setup was quite straightforward and in line with other people doing this work. We used Anopheles fenestis and Anopheles gambiae, which are 2 of the major vector-carrying mosquitoes in South Africa, from the NICD labs, actually just down the road here. And inside a climate-controlled room, we can subject these mosquitoes to various regimes of light, basically by using short pulses of light outside of the day-night cycle. So we can adjust the lights experimentally. We're basically focusing on spectra and intensity. There are all sorts of other aspects of light that we didn't get to, but those we felt were really important. And we can control for things like temperature and humidity that we know is important for changing aspects of mosquito biology. You can measure a whole range of things, but what emerged for us is really important is biting propensity. So how often these mosquitoes bite and feed in relation to artificial lights. And so early on in the work, Mr. Nicky said to me, well, does it all work? Is this all panning out? And so the short answer is yes. We could pull together as a first outcome that artificial light at night really is a modulator of mosquito biology. Again, this is a simplification of the results, but blue light at very high intensities can reduce feeding in both these groups. But there were a couple of surprises along the way. And so we can't quite duplicate results which we found elsewhere, and we identified a lot of geographical and biological variation within colonies and within species. So there's a lot of variation. You can see those error bars. And my student, Leila van Sail, focused on using lights that you can get at a household scale, that you can buy at a store in one of the experimental conditions. The reason being that typically most of these experiments use very narrowband spectra, and they use intensities at very high levels, which is almost sort of unnatural in nature. And she could show that there's a reduction in feeding with all these different lights, CFLs and LED lights, but only incandescent lights are showing a significant effect, despite controlling for temperature and humidity. But drawn together, we can our work and work of colleagues, this has become a really active field. We must consider artificial light in disease transfer. Okay, and so one of the major challenges really was to measure artificial light use at local scales. And this turns out to be a really fundamental and quite complicated challenge. It's keeping a lot of us really busy to try and advance this. At least for this project, this didn't exist when we started the work, but we've adopted what's called the environmental light field technique, by the Lund Vision Institute in Sweden. And basically, it uses a camera system to measure light. So the photographers have known for 200 years, cameras are fantastic at doing this, and the biologists are catching on. But basically, use a spherical camera, and you can build a 360-degree, depending on what you're trying to do, you can build a 360-degree sort of image of the average light conditions in an environment, like a room or even a habitat. And so the real magic happens in the software that comes with the data, and you can extract really important information about the whole scene environment. So the intensity of the light, the contrast span, and also the spectral composition of the light. And so this was really a big advance, I think, in how we measure artificial light for a range of reasons. And we were fortunate to be able to deploy this in, they're obviously case studies, but across South Africa, Mozambique, and Uganda, and I'll show some of those results. So this sounds like a very simple outcome, but it's quite, it's one thing making the claim, but it's quite another to go and collect the data. What you need to take from the left-hand graph really is that both inside and outside houses across these different project sites, even at the household scale, light use varies enormously. This is mainly LED lights we found in the survey. And so like much of the world, people are predominantly switching to LED lights. But yeah, like I said, the key take home there is that there's an enormous amount of variation. The graph to the left is the median light variation across these sites within a country. And we can show that in Uganda and South Africa, there's more or less the same intensity of light. But in Mozambique, it's almost an order of magnitude lower in intensity. And the reason being, in this case at least, that a lot of those lights in those villages are solar powered. And so they're at lower electrical or lower intensities. And what's called in the sustainability world, grid penetration hasn't happened in those communities. Okay, and so that means I guess the take-home from all that slide is that there's an enormous amount of variability in the light use itself, which will become later really important for our story. Okay, and so remember that these two steps was a lot of effort to build or to capture calibration data, which is really important. Okay, and so we're fortunate that the mosquito world, this is one of the reasons they're such an interesting study species. There's an enormous amount of data because people have been putting such a lot of effort trying to eradicate malaria and trying to understand what makes them tick. So we have very fine-scale data on when they rest, when they feed, how they prefer to feed, and basically these vector capacity models is a state transition model where the probabilities of different events affect the chance that malaria will occur, right, or be transmitted into a person. And it's important to emphasize that this is actual data, right? It's taken a lot of work to put all this together. It's been recently packaged in that packaged Anopheles model. It's not in R yet. I got access through this through Swiss colleagues. And basically now that we know by how much different kinds of lights reduces feeding and how people interact with different lights, right? So artificial light might extend the period of time that people are exposed to when mosquitoes are active. Okay, so in short, the results are not quite what we'd expect because the effect sizes are really small. You can just compare the red line and the blue line. These are actual interventions of long-lasting sprays and indoor residual spraying, and they have a pronounced effect at long coverage at reducing vector transfer. But lights, even and this is a sort of a null model where we are shining very strong LED lights over a long time period, it has much less of a reduction. And I showed this to some of the modeling people, and they said to me, it's because you're not killing them, that's why. And so what's happening is it's a very short-term masking response. It might last even if the lights are off. But basically, once these females are mated, they really want to have a blood meal. And think about it, every time you squash a mosquito, you've overcome that evolutionary drive to feed, right? They'll put up with that risk because they really want a blood meal. Okay, this is still under construction, but we've also we're pulling together a meta-analysis of all these different effects of lights on mosquitoes across different research groups. They're all looking at different things. And the take-home, again, from the meta-analysis, consistent with the rest of the literature, is the enormous amount of variability within species and across different effects. So despite these effect sizes being so small, this was some additional work outside of the initial grant where we piggybacked on research that was done by the NICD. They have a long-term monitoring project in northern Natal. And most traps to capture mosquitoes for monitoring uses active sampling. So you put out a CO2 bait or you put out lights and it attracts the mosquitoes. But here, fortuitously, they use these clay pot traps. And basically, the mosquitoes like to rest in these, but it's a passive sampling technique. So it's an interesting way to sample by not attracting them. And in these sites, we could duplicate these light measurements across this gradient of artificial light and also inside the system. So we were quite lucky to get access to that data. And so the data is complicated, the data is messy, that's true for a lot of ecological data, but we can still pick up this significant effect of a decline in anophelines under white light intensities. So despite not picking those strong effects up in the lab, at least for these African groups, we can show at scale that there is some interaction with these artificial lights. So the plot almost really thickens. Okay, and so the fifth outcome is we sort of drew all this together and wrote a paper about scaling these impacts across very complex socio-ecological societies. And so the scaling of this initiative is one of the classical wicked problems in conservation because of the multitude of trade-offs in that as an intervention. And so it's unrealistic to expect a household to follow some of the recommendations of a very intense blue LED light throughout the duration of an evening. And introducing the light itself outside of the household is a pollutant. We know that biological systems react very strongly to different kinds of LED lights. And so there's almost this trade-off between gains in reduced vector capacity, but also using light as a intervention. Okay, and ultimately the World Health Organization requires field trials to take this to the next step, right? That's their sort of litmus test of how this works. Okay, but it turns out to be a more complicated issue. So I'll leave you with that story, but I just want to spend a bit of time on the acknowledgements because they're really important. And so firstly, thanks to the Oppenheimer family. You've been exceedingly welcoming to myself and my family, and I really appreciate it. I think you've created a wonderful grant mechanism in Jennifer's legacy, and I'm humbled to be part of it. The Oppenheimer Generations group, Duncan and your crew, it's been a pleasure to work with you. You all have one thing in common, and that's that you get shit done. And it's great to work with people that are so proactive and getting outcomes. There's been an army of collaborators to make this work. Professor Kevin Gaston is an audience, thank you. Also Isaac Smith and Lizette Kukumur. A range of students and friends and family also supported the work. And I would stress...
They go to the dark things in the room so you can't find them. My first question is, have you noticed that? Have you studied it?
Yeah, so that's a quick overview of a complicated issue. It depends on the group, right? And so some species are photophilic and some are photophobic. I think you're referring to anopheles in particular. So the whole scene imagery really works on the average conditions of light, right? But those small, nuanced little pockets are really important for contrast. So that's an important level to try and push the work.
And then the second question might have been answered by the first one, which is in the cities, they hide when you turn on the light, but in the rural areas, they don't. And is that just a species difference, or is that a learned behavior? And I say learned in the facetious sense of the word.
Sorry, I didn't quite get the first bit. The difference between cities and urban lighting, or choices on lighting?
In the cities, they hide when you turn on the light, but in the rural areas, they don't. And is that simply a species difference, or is that a behavior that's evolved, if one wants?
But how do you know that?
From observation.
Well,
personal observation.
Yeah, I don't have data to support that in either direction.
Sounds like something I should follow up on.
All right, thanks.
Thank you, Bernard. Up next, we have Titu Rakutuzweli, who will be speaking to us on Daryl Jones for conservation in Madagascar.
Hello, everyone. So To start my presentation, I will ask you for 2 seconds to look at the ceiling, please. Thank you. So the things you've did before is my 60% of time work of position, like this. Because I'm working with drones, and I'm always looking to the sky. For my presentation, I will share with you how we integrate drones in conservation efforts in Madagascar, especially for our sites. So we manage 5 sites, main sites, but we have 2 other sites who's dedicated for captive breedings. All of those sites have their specific activities, but the main one is the mapping, the reforestation assessment, fire detection, and safety assistance. So since 2019, we started working with Liverpool John Moores University. They are using drones for conservation and conduct a lot of research about how we can integrate new technology for conservation. So for this site, we are using drones for aerial patrol, improving the protection efforts for protected area. We have ground patrol. They are making patrol twice a day, every week, but there is a lot of site, a lot of area where very, very difficult to access. So adding drones with this activity help a lot to detect as quick as possible the illegal activities. This is one example for 2 years ago during bushfire in Bali Bay. So at this time, we used a drone with combined thermal and RGB camera to help firefighters to avoid to be injured. If you look on the RGB camera on the left, there's 2 objects moving. Those people were stuck nearby the flame at this time. So using the drone with speakers on it allowed us to guide them getting out of this area with very difficult access. We started to put in place a standard protocol on how to conduct illegal activities inside the protected area. And we try to share this methodology, the best practices, with all our partners working in conservation, especially in the southwest of Madagascar, we call Menabe, and with combining the combination of drones, AI, and GIS allows us to check and to verify every data we received from ground patrol and improve our data set for future analysis. The second point is lemurs detection. This is the main point we are working with Liverpool John Moores University. We started 3 years ago using thermal cameras. The area, the habitat, the natural habitat of Banju, or the Apalimur alochensis, is bamboo and papyrus. So for the traditional survey, we have to take the pirogue, following the channels, and look with our own eyes. This is the traditional method. And every dry season, the Banju has the same color as the dry bamboos and papyrus. So it's very difficult to identify and to have to observe this amazing lemur. So we started to use drones for inventory and for detection. The first version just allows us to detect some points on the screen. But 2 years ago, there was a new version of new sensors, more improved, and we can get this result. If you look on the left, this is the standard RGB detection, so the standard camera. you can see nothing in the vegetation. But on the right, you can see small white points. Those points are the lemurs living in this marsh. With the combination with AI, we developed with LGMU the algorithm to detect the object, the thermal signature, and the behavior of the lemurs that we can say that this is a boundary. It's still in progress, but we have good results. We are also using conservation AI with Professor Serge Wick. And for this year, we conducted a workshop to allow students, other NGOs, governments, staff, to learn more about artificial intelligence, how to build machine learning, and how to create their own model. This conducts us to this next point, is reforestation effort monitoring. If we have 50 hectares of reforested plot, it takes time to count every young tree. With drones, you have to fly for 10 minutes at 70 meters high. You cover all the area. Enter this data into your AI algorithm, use photogrammetry software, and we can count how many young trees are present on this plot. At the same time, assessing the tree growth takes time. So the next step was to create 3D model of the reforestation plot, create the orthophotos, and extract the digital elevation model, which when we compare from last year and this year, DEM, we can find the difference between the young trees, and with ground measurement, we can have more accuracy, so we can give so that these species have grown 2 centimeters, 5 centimeters. These things we can do with satellite imagery, but with drones, we are able to do that. With LiDAR sensor that we are using recently, it helps us to increase the accuracy during our analysis. In this slide, you can see visually the difference between the T0, the time one, and the year after that, the cover, the tree cover. So it's very helpful, and it can improve our assessment for reforestation efforts. For every year, we are asked for giving a report about how many hectares left forest in Madagascar. When we are using satellite imagery, sometimes there are small or big difference. That's why we are using drones with different sensors, multispectral, RGB, and LiDAR, to help us to classify the land cover for each protected area we managed and where we are working now. So we are able to provide most accurate report near the realistic one, instead of saying, okay, we have 50 hectares left or 10 hectares, but we can check the accuracy, and we have more data to compare with the ground truth. The next point is the trial of mangrove restoration using drones. So this project started in 2021 with the Ministry of Environment. We've been asked to create a heavy-lift drone which can carry more than 20 kilograms of seeds, and which can reach more than 5 kilometers at least in the inaccessible area. So we built we created this heavy lift drone and started the trial in 2022 with Avicennia marina seeds in the mangrove at the southwest and the west coast of Madagascar. So this is how big the drone is. It can carry up to 45 kilograms of seeds and can go with the maximum range of 5 kilometers, but the regulation limits us to 2.5 kilometers from the takeoff point. So after different trial, we were able to put in place the best practices on how to use the Evolutionary drone. So it takes 2 people to operate the big drone. It can make 3 flights per day, depending on the tide calendar, and it can reach very difficult access area. For example, the mud in the mangrove at 10 a.m. it becomes very hot. So it's very difficult to reach this place if we want to plant mangrove manually. So we have some statistics on the success rate during the last 2 years. And we will extend this activity for this year in Bali Bay in the west coast of Madagascar. So conservation activities is still teamwork and collaboration. So we are conducting drone training for all the partners in Madagascar, including Ministry of Environment staff, students, different NGOs, about regulation and how to operate drones in the legal and safe manner. So we are working with the Civil Aviation Authority, the Ministry of Environment, and at the same time with other students at LGMU. So this year, 240 people have been trained in drone operation, especially for conservation, mapping, lemurs detection, and the protection. After this year, we had 2 workshops. The one with the Civil Aviation Authority, because in 2015, drones have been prohibited in Madagascar. 2017, you have to get special permission. And last February, we've put in place the new regulation which allow us to use drone in legal manner. So, I arrived at the end of my presentation. So this is my first conference.
Thank you, Titu. We have time for one question.
Thank you for that wonderful talk. Just a very quick question. With the thermal imaging of the lemurs, how high are you flying the drone?
Yes. So to avoid disturbing the lemurs, we take as standard to fly at 45 meters high and with 50 meters far. So we are using zooming to the area where we found the lemurs. And then, because when you approach a little bit, they were hiding inside the papyrus and the bamboo, and you will not find them again. So 45 meters is the safe height, and 50 meters far is the safe distance. And we share this, let's say, best practice for all people who are using drones to detect lemur in the forest, marsh, or in other areas. Thank you.
Thank you, Titu.
Thanks a lot.
Up next, we have Michael Singer, who will be talking to us about how Evolutionary overcompensation for climate change protects butterflies for decades ahead.
Thanks. I'm delighted to be here. I'm going to give you a happy talk. Duncan said he'd like a happy talk towards the end of the meeting. And this is a cheerful story about butterflies being resilient to climate change. My co-author and I are not agreed about how resilient. I'll come to that at the end. But here's a study with which we have had no relation, but it shows what you would expect, that in general, evolutionary responses to climate change lag behind the change. The evolution follows environmental change rather than jumping ahead of it, as we're showing here. So what we're going to show is our butterflies in California have done an unexpected thing. They've jumped ahead of environmental change. The reason for this is that the trait that's evolving is governed by genes of very large alleles of very large effect. And when you have alleles that have very large effect, then evolution doesn't proceed gradually, so it doesn't necessarily hit the selective target, the target of selection. And in this case, perhaps by accident, what evolution has done is jumped ahead of environmental change. Jumping ahead of a fluctuating environment does you no good at all. But in this case, the environmental change is climate change, and we expect it to go on in the same direction for decades and decades. So by jumping ahead of current change, the butterflies seem to have protected themselves for decades ahead. I'm going to talk about this in detail, but before, I'd like to talk just a little bit about herbivorous insects and our relation with them and how we might look forward and thinking about our relations with them in future. Because herbivorous insects, we compete with them for food. We use them as biocontrol of weeds, and as we just heard a little while ago on one of the posters, and they're important for ecosystem services. So we really do need to know how herbivorous insects are going to respond to environmental change and how we should, in order to plan to deal with it. Parmesan and I have had a small spat, an argument, we might say, with Curtis Deutsch, who is pictured here, and doesn't he look self-confident? And he has reason to be self-confident. The paper I cite at the top is a classic paper showing that tropical invertebrates will be less resilient than temperate into the future using known thermal resistance. And it was the first paper to show that, and it's been proven correct by subsequent work. The paper at the bottom of my slide develops a model that correctly predicts mass marine extinctions in the Permian, and then applies it to the future to see what marine extinction rates are likely to happen here in different climate scenarios. Lovely. The middle paper, increase in crop losses to insect pests in a warming climate. They predict a yield loss of 10 to 25% per degree of warming. And to do this, they just use the effective temperature on metabolic rate. Increasing temperature speeds up the insect's metabolism. They're going to reproduce faster. They're going to get more abundant. Parmesan and I were horrified by this. And we cannot look as self-confident as Curtis, as you can see. But we submitted a letter to Science complaining or criticizing and saying that both warming and ECO2, the responses of plants and insects and plant-insect interactions to them are very complex and idiosyncratic. For example, some plants respond to extra CO2 by becoming more suitable for aphids and less suitable for caterpillars, and some do the opposite. It's not clear if we can predict that at all. And we argued that if you have a crop that's important, you want to know what's going to happen to that crop and its pests in the future, you need to do experiments, real experiments, simulate global change and see what happens. And that you cannot predict this by asking what the temperature effect on insect metabolism will do to insect population dynamics. Curtis replied, we draw a lesson from models predicting future climates that lack the, quote, complexity and idiosyncratic nature of climate processes. But by building from a few robust principles, they successfully capture the essence of climate patterns and trends. We can discuss this, and I'm not going to talk about this anymore, but I don't think that predicting population dynamics from metabolic rate is a robust principle. And so we have some disagreements here. Now I'm going to get back to the checker spot. I mean, I'm using this example to tell you I think we really need to make observations and experiments to understand how herbivorous insects are responding and will respond to global change as we go forward. And now back to our checker spot. It's adapted to different hosts at different sites, and this map just shows the distribution of eggs at different sites where I've worked. I first published this map in 1971. I started the work in '68, and I've been gradually improving this ever since. And this is important for response to global change because populations that use different hosts experience different climatic stresses because of different evolutionary trade-offs. The second bullet here says some populations trade fecundity against climatic stress, others trade predator avoidance, and in both cases the butterflies evolve to the limits of the climatic tolerance, generating a geographic mosaic of climate stress. I know that's not necessarily obvious what it means. Let me begin with an example. Populations that feed on short-lived annual plants, a female caterpillar, once she's got big enough to pupate and make a butterfly with 50 eggs, could do that. Or she could feed another week and make a butterfly with 300 eggs. Better fecundity. But you're a week later. And the host plant is an ephemeral annual. It's only available for a short time. It senesces. So the more eggs the female lays, the more of her offspring she kills by host senescence. And the butterflies have evolved to lay lots of eggs and kill more than 90% of their offspring. That's the way they've responded to the evolutionary trade-off. I wrote about this in 1972. I studied it for my dissertation from '68 to '71. And what happened, basically they've evolved themselves into being very sensitive to climate. Because any little change in the phenological relationship between them and their host could kill all the larvae instead of 95%. And that's what happened. And in 2002, the populations I worked on all went extinct. And the Stanford modelers made a model showing that climate variability was responsible to that. So that's the trade-off between fecundity and climate stress. And what I'm going to talk about mostly now is the trade-off between predator avoidance and climate stress. Here's our study site at Rabbit Meadow, which is a range central study site. That there aren't any rabbits and there isn't a meadow, but so be it. Here is the host of the butterfly, Pedicularis. And here are a couple of plants on the 17th of June this year. And here are a couple more plants on the 30th of June. Look back, look what's happened between the 17th and the 30th. The leaves that are sticking up have all disappeared, and they're just cut stems. The plants have been grazed. And about 40% of the plants were grazed this year between the 17th and 30th of June. So no surprise that when we started work here in the late 70s and 1980s, the butterflies dropped to the ground to lay their eggs at the base of the host, like you see this butterfly doing, tucking her eggs under the base of the plant. Why this interacts with climate is the ground gets really hot. Even though you're at 2,300 meters, maybe because you're at 2,300 meters, the sun has a lot of oomph in it. And in 2010, we measured 47.6 degrees next to a natural egg clutch, and we found that 48 in the lab, 48 kills them. So they've evolved right to the limits of their thermal tolerance in responding to selection to avoid predation. This is Parmesan and Pedicularis, photographed this summer. And they have something in common that you can't see until I show you the thermal version of the photo. Both of them are keeping their cool on a very hot background since the light colors are high heat. And this shows you, if you look on the right, look at the leaf on the left. The leaf on the left is almost touching the ground. You can see that in the visual photograph on the right. And on the left, you see that that leaf, even to its tip, is maintaining temperatures in the 30s, when the air is at about 26, but the ground is ranging from 60 to 72 degrees. really hot. You burn your knees if you kneel on this ground. If a caterpillar falls off the plant, it's dead in 2 seconds. So the ground is really hot, and these are measurements that show how much hotter than ambient air the egg spaces are at different heights above the ground. So as you go to the right of the graph, that's higher above the ground, and the x-axis there is the temperature difference between ambient. How much excess temperature over ambient do you have? So this year we measured temperatures over 50 degrees at sites where the butterflies might lay eggs underneath pedicularis leaves. So we really expect climate change to be affecting the balance between natural selection for avoiding predation and natural selections for avoiding thermal stress. Might we get rapid evolution? Yes. Look at this graph. These are natural egg clutches that we found, and we measured how high they were above the ground, starting in 1993, 2002. The black dots are from Rabbit Meadow that I showed you, and the 2 blue dots are from a second site where we only have 2 years of data, but the same things seem to be happening. So the eggs are now laid on average 21 millimeters above the ground. When we started, they were laid about 5 millimeters above the ground. A very large change in choice of site. And I should say, the eggs are the most thermally vulnerable life stage of this butterfly because the eggs can't move. Caterpillars and butterflies can go look for a cooler place. Eggs can't. Chrysalises can't move either, but they're formed much earlier in the year in cooler conditions than the eggs. The eggs are in June, July, and midsummer. So this is important, the evolution of egg height. And on this graph, the dotted lines show you the starting condition in 1993 with the eggs at 5 millimeters, and the current conditions in 2019 and 2022 and 2024 with the average egg height at 21 millimeters. And the red arrow shows you how much average temperature change in the egg spaces has occurred. The egg spaces are now 7 degrees cooler than they were, and the regional warming's been 1.8, including the regional change in maxima as well as average. So that's what I mean by saying these butterflies have overcompensated for climate change. The average eggs are now much cooler than they were. They didn't need to be that much cooler to compensate for the change in climate that has occurred. The 2 evolving populations contain genetically based variation in behavior. This slide shows you a balancing butterfly that landed on the plant, balanced on the plant, and is laying her eggs, and you should just see the eggs if you're close enough on this plant. And at the bottom of the slide, there's a butterfly that dropped to the base, like the one I showed you earlier in the presentation. So in the 2 evolving populations contain both of these behaviors. There are populations where everyone drops and everyone balances, and we crossed these in the past, and we found that balancing was dominant to dropping. The genetic basis of this difference seemed to be very simple. So, are the eggs now more susceptible to grazing? Yes, they are. We've seen them grazed off this year. Here's a picture in 2019 of a very narrow escape. This little egg clutch is laid next to 4 petals that have been grazed off, and where the eggs would have been grazed if they'd been placed slightly differently. So, in brief conclusion, evolutionary trade-offs can cause adaptive evolution into climatic stress, far from range limits. Climatic stress is distributed as a mosaic across the species range. We found overcompensating, seemingly protecting for many decades, but predation is increasing. Parmesan and Singer disagree about the likely long-term outcome. Parmesan thinks the increased grazing puts the population at risk. I look at the amount of scramble competition that currently exists. I can find sometimes 6 egg clutches on a plant when only 1 or 2 can be supported, and I think the reduction in competition will compensate for that, and the population may stabilize at a lower density. But these butterflies are going to be at Rabbit Meadow after we are living in Mad Max movies. That's what I think. Well, let's hope not, right? I did say this would be a happy talk. All right, we're not going to live in Mad Max movies. Parmesan and Singer have been disagreeing for a very long time. Here we are disagreeing about how to pack the truck. Recently, our research has been mostly just the two of us. This last year, Gabi Montejo-Kovacevic joined us and is working out the genomics of the adaptive evolution that we've observed. And I'll leave you with a sarcastic, short biodiversity poem that Kevin Gaston, I hope, would approve of. Thank you very much.
Thank you, Michael. We'll squeeze in one question if anyone has a question for Michael. Okay, no questions. Thank you. Up next, we'll hear from Conservation International and the Future Ecosystems for Africa program on an exponential roadmap for Africa.
No? Yes, great. Hi, good afternoon, everyone. Wonderful to be here. If anyone needs to also just stand up for a second and stretch and just sort of breathe a little bit before this really exciting final panel session, there we go, exactly, is going to go ahead. Please feel free to do that. I know that's exactly what I needed. We can stretch. In the meantime, I'm going to introduce myself. My name is Laura Pereira. I'm a professor at the Global Change Institute at Wits University, and I'm here with a fantastic panel. I've got Julia Levine from Conservation International, Edwin Mashinga from UNESCO IOC, and Kim Zoyler, also from GCI at Wits. And we are going to give you what is fast becoming the annual update on the Exponential Roadmap. That is a collaboration between Conservation International and the Future Ecosystems for Africa program that is being funded by Oppenheimer Research and Conservation. So basically the run of play is going to be Julia, who's going to give us a general introduction to the background of the roadmap, sort of how it started from the global level and sort of how we've moved into having a more regional focus. Edwin is then going to step up and sort of talk to us more from a practitioner, decision-making perspective as to why this is such a critical bit of science policy work that needs to be done. And then Kim is going to come up and just sort of delve into a little bit more around the need for this African regional focus, bringing in diverse value systems, not just focusing on carbon sequestration, but also extending into nature's contributions to people, biodiversity, and development needs. So, without further ado, because I know lunch is calling, if I could hand over to you, Julia. Thank you.
Great, thanks. Good morning or good afternoon, everyone. So I think we've been here all week talking about a range of different natural climate solutions, but very much from a science perspective. And the work that we're trying to do is to make science available to decision makers, the people who write the policies, who write the checks, and to try and find a bridge between the very deep science around what natural climate solutions might look like in Africa and the high-level decisions that get made every day about what interventions to implement on the continent. So we're trying to Africanize what was a global roadmap for natural climate solutions. And the first obstacle we hit was our title, which is still a work in progress. But it is a roadmap for enabling just system transformations for Africa's people and nature. What does this mean? Africa has incredibly abundant ecosystems that have the potential to contribute at least 18% of global responses to climate change. What does that mean? It means that we can protect, manage, and restore our abundant ecosystems in such a way that really has a significant impact on our rapidly changing climate. But what we'd like to do is do that in a way that is uniquely African. And what does that mean? It means we're not just looking for carbon solutions. We're looking for solutions that help people adapt. We're looking for solutions that prioritize biodiversity. And we're looking for solutions that really balance the trade-offs between sustainable development and our changing climate. Now, many of you might have heard of these broad categories of natural climate solutions: protect, manage, restore. Those were first introduced by Bronson Griscom et al. In 2017. And it was wonderful to have a scientific review that listed all the things we can do with nature and for nature. But it's been quite difficult for people to decide, what must I do, where, and when? So what the global roadmap did was take those broad categories and break it out into a series of action tracks that then link to solutions and people in different parts of the world, and really try and prioritize what are the most urgent actions that will have the biggest impact in the shortest period of time. So this is not the full universe of what we can do. It's, if we could do 3 things, what are the 3 things we should prioritize in the area where we work, and how might that affect people on the ground? So in reviewing the global roadmap for Africa, we really started with trying to understand, are these natural climate pathways that have been proposed globally relevant for Africa? And if they're relevant, how? So this is quite a complex piece of work that Laura and the team have been leading, but really it goes to trying to understand the categorization, and are global categories relevant in Africa? So for example, one of the global categories is no deforestation supply chains. But in Africa, that's actually a far more nuanced category that really looks at reducing land conversion in a range of different ecosystem types and a range of different supply chains. Similarly, if we're looking at critical climate protected areas, in Africa, we want to have biodiversity prioritized next to climate. So we've gone through the list and really tried to understand, not to move away from the global targets, but to bring them down and make them relevant for Africa. Another one that was quite interesting is globally a diet shift, and food waste is quite important. In Africa, it's really just a focus on food waste. And then lastly, a big hole in the global roadmap was really around oceans and their contribution. So we're doing some really interesting work around oceans and coasts and their contribution, because Africa has such a significant coastline. What does this look like back in the laboratory where Sally and Kim and Laura are busy working? Is it's really getting into the detail of the data to make sure that we're using African data, comparing it to global data, and checking that the projections and the recommendations are accurate. So for example, we know quite a lot about grasslands in Africa, and so instead of just having a broad category around, climate smart grazing, we're really looking for a detailed assessment of what savanna, grassland, and woodland management might look like. And we've got the fire models and we've got the grazing models to be able to overlay onto global data to make more specific recommendations. Some of the categories, there isn't a big difference. So for example, with reduced peatland degradation, if you're doing it in the Amazon, or if you're doing it in the Congo, it's the same basic method, and there we're really just making sure we've got the right data. So why does this science matter, and why would we want to spend so much time rethinking quite detailed work? And that's really to make sure that the decision makers have the tools and the nuance that they need to make the right decisions. Firstly, we need carbon investment frameworks that are particularly suited to African needs. We also need policy positions for negotiations, such as the African Group of Negotiators, that are based on African data and not global data, because as the team will start to show in the next few months, there are some significant changes. We also need to make sure that financing solutions, climate finance solutions for Africa, really prioritize African values and put African perspectives first. One of the biggest ones is putting adaptation at the center of our mitigation agenda in Africa, which is not the case in many parts of the world. And then lastly, we want to make sure that adaptation really understands what a just transition looks like and that it prioritizes people. So this is quite urgent work because people are making decisions every day. So this is just an example of a decision that was announced in New York Climate Week a few weeks ago. The initial group started a year ago. So this is 11 African heads of state who've come together because they believe that protecting and restoring miombos is a significant climate solution. There's a big European company who wants to give them $500 million. So contrary to what people think, governments and decision makers are trying to do things, but do they have the right data? Do they have the right approaches? Or are they just copying from large global data sets and applying quite a rough approach? So this work is really urgent, and we hope to launch the final roadmap at the COP Belém next year. But along the way, we're trying to make recommendations as we go. All right, so how can you help, and why are we talking to a bunch of scientists who really have their head in the detail? So firstly, we want you to have an opinion or be curious about what your research means for natural climate solutions and natural climate pathways in Africa. It doesn't help that you know about this very detailed solution if the decision makers don't know about it. So before you say, well, this is not about me, just think about each and every bit of research and what it tells us about the African situation and how that may influence decision makers who are leading solutions to climate change. And then if you have specific case studies for natural climate solutions in Africa, we would love to see them and use them and share them, because a lot of the nuance actually emerges in a case study when you can see things are not so straightforward. We're also looking for raw data. So the Future Ecosystems for Africa have a lot of data, but they don't have all the data, and we're particularly short on some of the data for the forest work and food waste. We've got a lot of grassland data. I'm sure we could take more, but those are the two topics we really need inputs on. And then lastly, at the center of all of this is not just African science, but also indigenous knowledge. So we are working with the indigenous people and local community centers, but if you have case studies or academic research that can help bring indigenous perspectives into NCS pathways, please do share them. And I've just put Sally and Parushan's emails there, but you can find, just contact anyone at FIFA or Conservation South Africa and we'll direct you. Okay, so these are our current partners. We're working with lots of people, but these are sort of the core contributors at the moment. We've mentioned very generous support from the Oppenheimer family. We've got the Africa group of negotiators helping us think about policy, University of Cape Town, University of Pretoria, FIFA, UNESCO, and the Conservation Alliance, the African Data Drive, and the Social Ecological Observatory for Southern Africa. So I'm going to hand over to Edwin to talk a little bit more about how this helps decision making. Thanks.
Well, thank you, Julia, and you have really highlighted what the NCS roadmap really wants to achieve for Africa. And since I come from an ocean-based organization and background, I think my perspective along the stakeholder view on how useful the roadmap will be biased along those lines. And in terms of IOC, the Intergovernmental Oceanographic Commission for UNESCO, we are coordinating the UN Decade for Ocean Science, 2021-2020 to 2030. It's 4 years in operation now, in implementation. And I think this roadmap is a crucial resource in the implementation of the UN Decade for Ocean Sciences. When we were developing the UN Decade for Ocean Sciences, and in an African perspective, we had a group of experts come together and they put together the Africa roadmap, which prioritizes the thematic areas that we are going to focus as an Africa in terms of the UN Decade for Ocean Science. And critical to it, one of the priorities is unlocking the blue carbon potential for Africa. And this roadmap comes to answer that question and will drive that priority of the Africa Ocean Decade roadmap. And this is how. The roadmap will help us in terms of addressing data gaps in new and potential marine ecosystems like the seaweed and kelp ecosystems that are gaining tractions around Africa, seaweed farming in Zanzibar, kelp farming in Namibia and South Africa. All these, there are data gaps. We don't understand the potential of these ecosystems in terms of sequestration of carbon, first of all, and also in terms of helping the African continent and African people to adapt to climate change. As Julia mentioned, adaptation is a critical priority for Africa in climate change discussions. So we are hoping, and that's why IOC is one of the partners in this roadmap. We are hoping that this roadmap will address those data gaps and will help us to know the importance of these ecosystems. Additionally, it will ensure that we understand the importance of protection and restoration of marine ecosystems to ensure the maintenance of healthy marine ecosystems in the region. Africa people are highly dependent on the ocean, and the blue economy is a good platform for Africa to enhance its economic potential. And that is why we are going beyond the carbon values in this roadmap. We are looking at livelihoods. We are looking at food security. We are looking at the adaptation goals for Africa. So that is crucial also in terms of this roadmap. Then it will also help us in understanding the socio-economic potential of marine and blue carbon ecosystems. Then, critical to that, it will provide data and critical data for decision-making and planning for African governments along that line. Another aspect is on climate finance. We all know that SDG 14 is one of the most least funded SDGs, and the roadmap will look into the flows of climate finance in Africa and how that climate finance will address mitigation. Yes, a lot of mitigation finance is coming in the continent, but with adaptation priorities for the continent. So it will help nations and governments understand the way climate finance is flowing and how those mitigation finance can help in addressing the adaptation priorities for Africa in the climate change sector. So then it will also, we've seen that NDCs, National Climate Mitigation and Adaptation Policies, the framing and the drafting of these NDCs sometimes excludes the critical marine and coastal ecosystems. So the roadmap will advocate and will ensure that there is an integration of marine ecosystems in national climate change policies like the national determined contributions and the MBSAPs for the GBF, so that coastal, because we know the ocean is both a solution and a victim to climate change narrative. And it is important for coastal ecosystems to be factored in those national climate mitigation policies. And I think it will also be a way of highlighting best practices in an African context, how Africa is conserving, restoring, and protecting its marine ecosystems for adaptation, livelihoods, and food security. And it will give an opportunity for scaling up those initiatives and replicating those initiatives in different African countries. Thank you so much. Over to you.
Thanks, Edwin. Over to you, Kim.
Thanks, Edwin. Is this working? Yeah. So I'm going to be focusing mainly on how we can sort of scale these roadmap tracks down to the African context and how we can use non-carbon values to better understand how people and nature can benefit from the tracks. But first, I just want to reiterate that Africa is home to a really diverse range of ecosystems, as we've learned these last few days. And these landscapes have been created over centuries of interactions with people. And so this means that it's really critical that in order to properly understand the climate mitigation potential of Africa, it's important that we understand these interactions between people and nature. And so part of what we're really trying to do is to ground our tracks into the priorities of the African people. And this is particularly significant as we move to COP29 and COP30, that we develop an evidence base for principles for climate action that are rooted in these African priorities. And this means that the natural climate solutions that we develop not only need to address the climate change problem, but also help address biodiversity and livelihood issues that are really prevalent for African communities. And so the roadmap is really useful in this way because it recognizes that in order to do this, we need a holistic approach to understanding our relationship with nature and how that impacts climate change. And so this is where our team and all these lovely partners sort of come into play. We have developed a really good team with specific expertise. And we're reworking these global methodologies to tailor them to these specific social ecological contexts in Africa. And this allows us to generate better data and develop models that are really grounded by African roadmap principles. And I'm just going to give you some examples of the kind of work we've done so far. So you would have heard Fazile talk on Wednesday, and she is focused on quantifying resilience of African woodlands to better inform afforestation and reforestation priorities. We've also developed a technical report and a framework that helps to guide ecosystem intervention decisions with the African group of negotiators. And this sort of links us more to the African Union and African Roadmap and the natural climate solution space. And then Sally, who spoke yesterday, has produced spatial maps of stem growth and biomass accumulation rates, and this also helps inform African Roadmap, and it's really critical data that we can scale up to better address these climate issues. And then moving forward, as Edwin mentioned, we need to start paying more attention to the blue economy space, and to that end, we're going to be working with some colleagues to estimate the carbon sequestration capacity of marine systems, and this includes the high potential but unrecognized systems like kelp forests. And we're also working with our colleague in Ghana, Mohamed Amani, who is developing a queryable database on biodiversity and livelihood trade-offs. And sort of the main crux of what I want to say is that these natural climate solution interventions not only produce ways that can help us mitigate against carbon, but they also produce multiple benefits that can help African communities and biodiversity more generally. And we just came off a workshop where we try to define these non-carbon values more succinctly. Both Julia and Edwin alluded to some of them. They are adaptation and resilience, biodiversity, health and integrity, food and water security, and finally well-being and livelihoods. And this is particularly important in the context of the African roadmap, because we know that, and it's been sort of coming up as a through line throughout all the talks that we've heard this week, is that the benefits that nature provides people is pretty hard to quantify. And they produce intangible, tangible, and regulating contributions that help people improve their quality of life. And what we're really interested in doing is understanding how these benefits can coexist by adopting a pluralistic approach to understanding these different kinds of benefits. And ultimately, it helps us implement stronger science and make that science policy interface more communicable, and we know that we need to promote these kind of things with government and society and business to incentivize investment in natural climate solutions.
Cool. Thank you so much, Kim. So, I mean, to wrap up, in essence, we're really looking at African science and knowledge for the African context and peoples. And it's this whole idea of moving beyond just the carbon argument. We need to do mitigation, but not at the expense of adaptation of livelihoods or biodiversity. Sort of thinking about the need for sustainable use, not just stopping use. And I think, what you've all mentioned is, it's really putting African ecosystems on the map. So from grasslands to kelp forests, these are almost oddly unique in the carbon negotiation space, in the financing space, but they're really, really critical from an African perspective. And this link, I think this is the first time we're really seeing sort of active work around linking the marine and the terrestrial sort of data science knowledge holders together for decision making. So I have a mean question that I didn't pre-warn you about, so I'm going to sort of ask it and sort of let it simmer in the last couple of minutes, while I will also open up for one lucky member of the audience who can also ask their own question to the panel. And mine is really, there's a pushback that Africa shouldn't be offering the solutions to address the carbon appetites of the global north, right? So apart from the financial investment incentive, what are the other sort of benefits that African countries could be gaining from buying into this natural climate solutions approach? So I'm seeing some smiles, so I'll let you sort of think through that whilst I look to the audience and see if there's one question that we might want to ask. We knew that William was going to do it. Okay. He's been saving it all day. Please, could I get a microphone to William? Thank you. You're also sitting right in the light, so I had to see you.
Can I ask now? It's sort of useful to measure these carbon interventions against the rate at which carbon is increasing. So I try to do that from your first slide, which is indicating quantities. And I couldn't quite work out very quickly what that was all about, but it comes to a little over 2 billion tons of CO2, and that accounts for 11% of 1 year's increase in global CO2. 1 year. So do you think it's worth it? Where all of that stuff is worth 11% of 1 year's increase. Isn't it just a fraud, basically?
Is it not a flaw in what, sorry?
A fraud.
Isn't nature climate solutions a fraud relative to the rate of increase of CO2, largely from fossil fuel use? So it's a sop to people to pretend that this is going to make a difference. Will it really make a difference where we have these big interventions in Africa and it accounts for about 1/10 of 1 year's increase being driven by fossil fuel use?
So I think that's almost similar to my question, right? So I'm going to hand over to them, and then I'll also try and sort of...
Thanks. So I said to Laura, no hard questions, please, but I take it that she didn't listen. So I always like to think about the last ice age and the impact that that had on the current levels of biological diversity and why African biodiversity is what it is today. And it's not what it is today because there wasn't an ice age. It's what it is today because during that ice age, there were tiny little pockets along the southern tip of Africa that weren't fully covered by the glacier. There were tiny spaces that were not affected, but they were not as dramatically affected as the rest of the continent and other parts in the world. And as the climate changed in that natural cycle, these little hotspots of genetic diversity that had somehow come out a little bit stronger than other areas have had exponential impacts on global biodiversity in the time since then. So it's not a perfect argument, but I do believe as a practitioner rather than a scientist that doing nothing is worse than doing something. And while we can't control the global climate, what we can do is try and make sure that African ecosystems are as robust as they can possibly be, and that African people are as informed as they can possibly be. We will not prevent catastrophic change, but can we create a higher degree of resilience in a few places that might give us a better chance if the globe does not prevent catastrophic climate change from recovering and holding on to some of the gems that we currently have. So we're definitely not proposing a sort of carbon silver bullet. In fact, what we're trying to do is show that the global carbon response and the global carbon market is not actually addressing some of the core needs, which is to highlight resilience as much as it is to try and prevent change. And I think really our philosophy is just do what you can with what you have, and what we have is African ecosystems. So we're going to do what we can. Thanks.
If I can...
Okay.
If I can also add to that, William, carbon is one of 3 pillars of the African roadmap, and I agree with you, in the grand scheme of global emissions, it really is a drop in the ocean. But having spoken to policy representatives within CI, it seems like the best way to leverage funding is via carbon sequestration potential. And we know that global biodiversity loss and carbon emissions are two sides of the same coin. And if we can leverage that funding for climate mitigation approaches to better enhance biodiversity and improve local livelihoods, I think it's kind of, a three-pronged approach.
I think Julia and Kim have highlighted what we think. When we are looking at the roadmap, we are not just looking at the mitigation. As I said in my intervention, that we are prioritizing adaptation in Africa. And our ecosystems have much more value, other values than just sequestration potential. So we are looking at the cultural aspect of these ecosystems, the protection aspect, the provision functions of these ecosystems. And that is why this roadmap is crucial. We are not just looking at the carbon benefits that result from ecosystem, but key to it, the adaptation, livelihoods, food security, and the biodiversity potential of these African ecosystems.
Thank you so much. And I will also take the opportunity to answer my own question in a very Lara fashion. So I think, we've emphasized that we're moving beyond just carbon, right? That carbon is kind of a means to start opening up the importance for adaptation, for improved livelihoods, for biodiversity conservation. But as has been pointed out by the panel members, the money, the finance right now is flowing around those carbon numbers. And I think that's something that we need to prepare our decision makers for, to actually show where there can be some co-benefits, but actually where there might be really big trade-offs. And sort of we're going into a moment now, we're about to head off to COP16 in Cali in Colombia, where we're going to be negotiating the global biodiversity framework, where finance is going to be sort of front and center of that. And a few weeks later, we're going to be going to, well, I won't be, thankfully, but going to Baku for the UNFCCC COP, where more finance is going to be talked about. And quite often, those aren't actually talking to each other, because the climate and the biodiversity negotiators, the financiers, aren't actually having that conversation. So I think this is a really great opportunity for us actually to bring both of these conversations that are happening at this intergovernmental space into the African regional context, to actually show if we're going to be doing something proactive around maintaining our ecosystems that are largely intact, the biocultural heritage that we have associated with that, we also need the finance to do that. The world needs to recognize the value of this. I think the hardest part is going to be about addressing those broader climate change drivers, which is around consumption, which is around the fossil fuel industry that operates globally. And we're not going to solve that problem, I think, by looking at carbon sequestration potential in Africa. But that is definitely a conversation that's front and center. Maybe something we can solve at the next conference next year. But anyhow, thank you so much to this wonderful panel for sort of concluding at this time. Time is officially up. And just a final round of applause, everyone.
Great, thanks. Thank you, Laura. Thank you, team. This is always a fun part of at the end of the conference, and that's the prizes. If I could call Nikki Oppenheimer up to award them. So before we get started with them, I'd just like to call up Duncan Mitchell. He's actually was a 2010 Harry Oppenheimer Fellowship Award winner, just to receive a small gift for Andrea Fuller, who has managed the team of scientists who decided on the winners of the different categories. Duncan. Thanks, Duncan. Then the poster session We've got 3 prizes, the second and first runner-up, and then the best poster. You know, a lot of time and effort goes into those posters, and I think they were spectacular this year. So the second runner-up, Mutsumishi Makunga. Is she still here? Yeah. Just that. So it's just a bit of 500. Congratulations. The first runner-up, Daniel Rousseau. Well done. No. Just the... That's huge. And then best poster, you get this floating trophy which you won't take home because we battle to get them back, but your name gets engraved on this fine piece. You keep that to remember this. And the winner is Laurie van Dijk. Well done, Laurie. Then the best presentation, speed presentation. And well done to Amy Chen. I must make special mention of the speed presentations. I thought they were all fantastic, and the judges did have a hard time, but you certainly were well deserved. Thank you. Then best presentation student for the conference, Chanel Ramatab. Well done, Chanel. This one's quite dangerous, got thorns on it. This is a new award for the most outstanding contribution across the board. And that goes to Amy Dickman and Lovemore Sibanda. Feeling very short.
Well, ladies and gentlemen, we're very near the end of the 13th Oppenheimer Research Conference, and it seems to go from strength to strength. And I think everybody, I hope, will go away from here inspired to change the world further than they are already. But I think what I need to do is pay a particular tribute to the Oppenheimer Generations team who put this together, led by the conservation people, Pumla, Rendani, and importantly, Duncan. So if we can give them all a large round of applause. And if there were another prize, Duncan would win that. And the prize would be for keeping the party going longer than most people thought. But thank you for coming, and thank you for being with us and sharing an important 3 days of wide-ranging, different presentations, conversations, dancing. I think this is a really important conference, and I think we show here what Africa can do in the conservation field. And it's really important that we do that we keep our feet on the ground, bare feet on the ground, and that we continue to change and save the world in partnership with nature, not imposing our will upon it. Thanks very much for all of you. And Duncan will go through the final formalities, if I can call it that.
I'll talk from this one. Sorry.
Give it to me.
As we come to the end of another, I think, fun, educational, and exciting research conference, I just wanted to say thank you to all of you for participating. It's you that makes this conference what it is. You know, over a decade of running this conference, we've been really focused on science that matters, and science that's going to make a difference. The networking opportunities that come with this conference are, of course, a further attraction. But sharing the research, learning from each other, and putting solid science behind decisions that we make are important. Of course, day one, we had a great keynote address from His Excellency, Hilberium Delsain, who were inspiring us on the importance of this conference, but not only that we should not just have lip service, but actually action is required, and time is running out. One of my favorite presentations of this conference, Professor Camille Parmesan, made me really challenging our thinking on climate change. And I mean, she's the second most highly cited scientist in the climate change space. So it was a great privilege having you here, and thank you for coming all this way. Again, we listened to the Managing Executive of South African National Parks, Dr. Howard Hendricks, who spoke about tipping points and the fact that some uncomfortable decisions and trade-offs may happen in the near future in South Africa to ensure environmental tipping points are not reached. So the diversity and topics of discussions on that day, I think, were outstanding, and I think including leveraging ecological knowledge, bridging the gap between land reform and biodiversity, the future of grasslands and why do we need to conserve grasslands, upwelling in the Benguela microbe biome, and through to trophy hunting, from a public furore to published figures. We were captivated by Jonathan. I know some feel his discussion touched on some really, really exciting but interesting and difficult topics. The business of conservation and debating whether conservation could be done according to business principles and how good business is good for the environment. We ended the day with CEO of Wild Earth, Andre Crawford Brunt, and highlights from that Wild Earth movie, Live Safari. And that, I see, reached over 7 million people coming from this conference. So I think we really got the word out that this conference is happening. Day 2, we had a brilliant presentation of highly acclaimed researcher and wildlife biologist Winnie Kiru on transforming spaces of research and embracing transformational leadership. She said to me this morning, and I don't know if she's still here, and I don't know if it's the conference or the party, but if this is what South African conferences are like, she's coming every year. So we had, again, a series of fantastic speed presentations, ranging from estimating leopard densities, black rhino, rewilding, effects of elevated atmospheric CO2s on dung beetles, testing possible drivers in geographic variation in zebra stripes, and then development of call library for small mammals. And I must just say again, I thought, and there was some skepticism about the speed presentations from last year, would it work? And it worked beautifully, and well done to you all. Again, I must say the poster session was outstanding, and I think it really, really is a highlight of this conference. And I think it shows the diversity and richness of what we're doing. So well done to all the posters. Well done. The rest of the day, again, was hugely exciting, very varied, and it went ranging from getting the grasslands on the map, priority conservation and the impact of rainfall and fire on acacias, rethinking natural resources governance for a low-carbon future. The panel discussion with the Oppenheimer Program in African Landscape Systems, run by Andy Cunliffe, was again fantastic to get student perspectives on the fantastic work that they're doing. Then the excitement around Jonathan announcing the new 2024 JWO Oppenheimer Research Grant. Well done to Dr. Shannon Conradi again, linking physics and biology to inform wildlife conservation under global change and the interdisciplinary approach across terrestrial and freshwater ecosystems. Today, I think, lived up to the first 2 days. I saw a number of outstanding, fantastic presentations, starting with world-renowned ecologist Kevin Gaston on personalized ecology. Following through with aligning, looking at developing capacity in marine research in the Western Indian Ocean, animal vocalization, and I really enjoyed Marta Munz's talk on the meerkats, very exciting, elephant movements in Namibia, and so on. We also saw the progress of the snapshots by Lova Moline of the last year's JWO and the final of Bernard Coetzier's work through JWO. So to all the presenters of oral and posters, I say it again, you've raised the bar. And it always worries me when we have a conference which I think is so diverse, that what are we going to do next year? The science community, as we all know, is vitally important, and people coming together like this gives Africa a voice. One of our scientists, one of our main core areas is developing the next generation of African scientists, and when I look around, I think we're all achieving that, and it's really, really exciting. Again, a conference like this takes a long time, and as one would know, a lot of people, a lot of effort goes into organizing a conference of this nature. I would like to thank Nikki, Strilly, Jonathan, and Carrie again for providing us the opportunity to have this conference. I was absolutely delighted to have Izzy here with us throughout the conference. Thanks, Izzy, for being here. As one knows, many conferences, one has an external conference company that helps one put a conference like this together. In our case, we don't have an external conference company. We do it all in-house. The Oppenheimer community, working for the Oppenheimers, all come together starting in February to start thinking about it. When it sounds like it's a far way away, we're busy starting thinking about it. And I think it really has paid dividends. So well done to the committee. I would like to mention a few individuals on that committee. One, Ricky Hollis. Thank you for all the IT support. We don't know what we'd do without you. To Ashley Finmunda and Greg Crockett, thank you for the app development. I hope the app was useful. I think it works pretty well. To Pumla Lamini, thank you for organizing pens, gift bags, etc., etc. Duncan Butcher for organizing a very fine party last night. I always think a cocktail function is as important as the science, as good science, because it creates a relaxed environment to network and really get to know people. I always say I always tend to get mixed up with the wrong crowd at these things, but Nikki reminds me regularly that I might be the wrong crowd. The academic committee, we have 37 spaces to talk in this conference, over a broad, varied diversity of kind of areas. And we had 268 oral applications sent in. And it was really tough to go through them and put this program together. But I think we did a good job. And unfortunately, those who didn't get a place, please reapply next year. And we're very thoughtful about balance in the program. And I suppose I can say it, we don't want just all old white males. So we have a diversity, and we focus on that. Then to Philippa, Vicky, and Teeks, I just want to say thank you. I think the catering was absolutely fantastic. That's another strength of this conference. I hope it's not too much of a strength. I hope we come for the science. But well done to Vicky and her team. Then to our communication partners, Jive Media, Robert, Eve, Mimi, thank you for all the work you've put into this. To Sabi, coming in at the last minute and helping us out. Henry, Alice, Saskia, and the team. We really appreciate all the effort. Katie Roxburgh, who's a strategic advisor for us, her involvement. And then Habitat XR for all the photography and videography. A huge thank you. Then lastly, and very importantly, to Randani and Pumla. You have been stars, and I don't know if we would be able to pull this conference off without the two of you. And I thank you, take my hats off to you, and well done. And then lastly, as I said, to the delegates, the presenters, the facilitators, and the panelists, thank you. I think we all pulled together, and it was wonderful to learn and spend time with you all. The dates for next year, 8th to the 10th October 2025. I know diaries fill up very quickly, so please put those in. And please remember the social media handles, and we look forward to having some of you here next year. Thank you.